Hello, fellow sapiens. Whether you're lying down, winding down, or just trying to silence the chatter of a very long day, welcome. This is Sleepless Homo, a channel for calm minds, slow science, and long-form history that remembers we are still just clever apes, staring into the dark, asking how we got here. So take a breath. Maybe you're preparing to sleep. Maybe you're working on something quietly, driving through the night, or walking with headphones through a noisy city. Wherever you are, or whenever you are, this episode is made to meet you there. If you enjoy this kind of soft science and factual storytelling, where there are no wild speculations, no flashy edits, just the quiet company of deep time and humble questions, consider liking and subscribing. It helps more people find these long-form journeys, and it supports a small project built on curiosity, not clickbait. And we'd love to know how you listen. Do you use this to fall asleep, to study, to shower with calm drama, or to stay focused while editing a spreadsheet about extinct mammals? Let us know in the comments, or just tell us what place and time you're tuning in from. Also, if you happen to drift off during one of the chapters, don't worry. I've added chapter timestamps in the description so you can pick up right where you left off. The story is worth hearing in full. And as always, stay curious. Stay calm. Now, tonight's journey. We're going back 50,000 years. To the moment before Australia was Australia. To a world where oceans were lower, coastlines were wider, and no human had yet set foot on the land we now call home. How did the first people reach it? Why did they go? And what was waiting on the other side of that impossible sea? Let's begin. Tonight, we begin with a continent that wasn't quite a continent, at least not the way we think of it today. Australia, the island nation that most of us picture surrounded by endless water, was once not an island at all. It was part of a vast, ancient landmass called Sahul, a now submerged continent that connected what we now call Australia to New Guinea and Tasmania. And this idea, the image of a larger, unified land rather than scattered fragments surrounded by sea, is where our story begins. Because long before the first humans set foot on Australian soil, before the oceans rose to swallow the coastal plains, and before the stories of the dreaming were etched into memory and landscape, there was simply land, a lot more of it. And that land shaped everything that would follow. To understand this submerged world, we need to go back roughly 130,000 years, to a time when Earth was slipping into the last great ice age. The climate was cooler, the polar ice sheets were growing, and more of the planet's water was locked up as ice. This shift had a surprisingly dramatic effect on global geography. With sea levels dropping by more than 100 meters, entire continental shelves were exposed, connecting islands and coastlines that today seem impossibly distant. Australia, New Guinea, and Tasmania became one single landmass. And not just any landmass, Sahul was massive. It spanned nearly 10 million square kilometers, making it larger than modern-day Europe. The Sahul Shelf itself is a submerged extension of the Australian continental plate. It includes what we now call the Arafura Shelf between Australia and New Guinea, the Gulf of Carpentaria, and the Bassian Plain that once linked Australia to Tasmania. At the time, if you were standing on the northern edge of this land, you could have walked from the present-day tip of Cape York directly to the highlands of Papua New Guinea without ever seeing the sea. To the south, you could have moved from the mainland to Tasmania through grasslands and plains that no longer exist. But even with these connections, Sahul was never connected to mainland Southeast Asia. That line, the water gap between the Sunda Shelf and Sahul, remained one of the greatest barriers early humans ever crossed. This oceanic trench, now known as the Wallace Line, separates the Asian and Australasian ecozones. It never disappeared, not even during the lowest sea levels of the Ice Age. That means the first humans to reach Sahul still had to cross open ocean, distances of at least 70 to 100 kilometers at their shortest. We know this now thanks to bathymetric mapping of the ocean floor and reconstructions of Pleistocene sea levels. But for early humans, none of this would have been visible. What they saw, likely from the shores of Timor or Sulawesi, were birds in flight, clouds on the horizon, or perhaps even smoke drifting from faraway fires. And they went. Now, it's easy to imagine these people walking across a broad plain and simply ending up in Australia. But that's not how it happened. because while Sahul was exposed, the region to the north, Sunda, was also a vast landmass connecting much of present-day Southeast Asia. Between the two, scattered across the Wallisan Islands, was a broken chain of land and water, and this, the Walliser region, was the gateway into Sahul. To migrate through it meant moving island to island, crossing deep water channels at every step. No land bridge connected Sahul to Asia, not now, not then, which is why the very presence of Homo sapiens in Australia is one of the strongest archaeological proofs that early humans had mastered seafaring far earlier than we once believed. For most of the last 2 million years, the Australian continent was silent, at least from a human perspective. While hominins were evolving, dispersing, and interbreeding across Africa and Eurasia, Australia stood apart, vast, strange, and untouched. It was a land of dragons, thunderbirds, and marsupial giants. But as far as current evidence shows, not one of our ancient relatives ever stepped foot on it. This is a strange fact, because for much of that time, hominins like Homo erectus were present nearby, thriving in Southeast Asia. They had reached Java by at least 1,500,000 years ago, possibly earlier. They survived there for over 1 million years. Yet somehow, despite being just across the water, they never made it to Sahul, the ancient supercontinent that included Australia, Tasmania, and New Guinea. The reasons why are still debated, and honestly, not well understood. But one thing is clear. When Homo sapiens finally did arrive tens of thousands of years ago, they were not stepping into someone else's world. They were stepping into an island continent full of animals that had evolved without ever seeing a primate walk upright. To understand what that meant, we need to take a quiet look at what this land was like in the long ages before our species appeared. Start 2 million years ago, in the early Pleistocene. Earth was locked in a cycle of glacial and interglacial pulses. Sea levels rose and fell, grasslands expanded, then shrank, and across Australia a unique ecosystem evolved in complete isolation. The continent had been separated from Antarctica for around 35 million years, and from Asia for even longer. As a result, its wildlife had drifted into forms found nowhere else. Instead of elephants, there were giant browsing wombats. Instead of big cats, there were carnivorous marsupials. Instead of hoofed animals, there were kangaroo giants over 2 meters tall. These creatures filled the same ecological niches as their African or Eurasian counterparts, but they had taken a very different evolutionary path. By 1 million years ago, Australia was home to an impressive array of megafauna. Diprotodon, the largest known marsupial, weighed more than 2,000 kilograms and roamed open woodland and grassland. Thylacoleo, the so-called marsupial lion, was not a lion at all, but a hyper-specialized predator with bone-crushing jaws. There were giant snakes, enormous flightless birds like Genyornis, and massive lizards related to today's monitor species. One species, Megalania, may have stretched over 5 meters long. To a modern observer, this might sound like fantasy, but the fossil record is remarkably clear. These animals existed. They flourished. And they did so entirely without hominins to hunt them, chase them, or shape their behaviors. That fact is critical to remember. Australia was not simply waiting to be colonized. It had its own long story in progress, and its cast of characters had never met anything like us. Curiously, while Homo erectus reached islands in what is now Indonesia, including Java and possibly Flores, there is no trace of them beyond the Wallace Line. This invisible boundary, named after the naturalist Alfred Russel Wallace, separates the biogeography of Asia from that of Australasia. West of the line, you find tigers, elephants, and apes. East of it, the mammals are almost entirely marsupials and monotremes. The Wallace Line also marks a profound oceanic barrier. Even during the lowest sea levels of the Pleistocene, a stretch of deep water separated Southeast Asia from Sahul. It could not be walked. It had to be crossed by water. And apparently, no hominin before Homo sapiens ever managed that crossing. Why not? We do not know. It could be due to cognitive limits. Toolkits found with Homo erectus suggest they were capable but lacked the complex planning and communication that true seafaring likely requires. It could be that they never saw land on the other side and had no reason to risk open water. It could be simple bad luck. Perhaps one group tried and failed. Perhaps they tried and succeeded, but left no archaeological trace. But until direct evidence appears, we can only acknowledge that Australia remained untouched for almost the entire history of early human evolution. No hand axes, no fire pits, no butchered bones, only wind, thunder, and the quiet footsteps of creatures that had never known what it meant to be hunted by an upright ape with language. The ecological systems that evolved here were unlike anything elsewhere on Earth. With no placental carnivores, marsupials took on roles typically filled by wolves or big cats. The marsupial lion, Thylacoleo carnifex, had retractable claws, slicing teeth, and a powerful bite force, possibly the strongest of any mammalian predator relative to its size. Wombats grew massive and armored. Kangaroos evolved for speed and endurance, and the birds got large, aggressive, and flightless. Genyornis, for example, stood 2 meters tall and may have been capable of delivering lethal kicks. These animals were shaped not by us, but by their own internal arms races. For tens of thousands of generations, they had been evolving in a world where humans simply did not exist. In the surrounding islands, things were different. Flores, for instance, produced something entirely unexpected, a small-bodied hominin known as Homo floresiensis. Standing just over 1 meter tall, with a brain about the size of a grapefruit, this so-called hobbit lived on the island as recently as 50,000 years ago. Whether they descended from Homo erectus or some earlier hominin is still debated, but they are the clearest sign that small populations could evolve in isolation on island environments in Southeast Asia. They are also a reminder that the absence of evidence is not the evidence of absence. It is still possible that future excavations could change what we know. But so far, no member of our extended family has been found in Australia prior to Homo sapiens. This matters because it sets the stage for what comes next. When anatomically modern humans first arrived, whether 50,000 or 65,000 years ago, they were not joining a crowded hominin ecosystem. They were not meeting Neanderthals, Denisovans, or archaic Homo erectus. They were stepping into an ecological vacuum, at least in terms of human competitors. This may partly explain why they were so successful. No other upright walker had preceded them. No other species had hunted the megafauna, burned the land, or painted on the rocks. In Australia, the Homo genus did not evolve in layers. It arrived in a single dramatic entrance and from there began writing its own local chapter. But before we get to that chapter, it is important to sit with what came before. The long silence, the ice ages and shifting rains, the slow evolution of marsupial giants in a world without us. Australia was not an empty place. It was an unpeopled one, and the life that flourished there had adapted to that fact over millions of years. What followed, the human story, is another kind of transformation entirely. But it rests on the strange truth that until very recently, this enormous continent, rich in forests and deserts and strange creatures, had never once been seen by human eyes. At least, not as far as we know. There is a moment in the story of our species when the map stopped being helpful. Not because people lacked maps, they didn't have any, but because something unimaginable lay beyond what they could see. A stretch of ocean so wide, so deep, and so empty of land that it would have turned back nearly any other animal. And yet, somewhere between 70,000 and 60,000 years ago, humans crossed it. They did not yet know they were human in the way we mean it now. They had no word for species, no idea they were on the edge of a continent that would one day be called Sahul, or that the water beneath them held a geological trench deep enough to swallow most modern skyscrapers. What they did know was simpler, older. They were moving, and the sea did not want them to pass. To understand what happened in this forgotten crossing, we need to look at a part of the planet that is rarely taught in school, Wallacea. A name that sounds like a kingdom but is really a biological no-man's land. It's the collection of islands that now form parts of Indonesia and Timor-Leste. But in the Pleistocene, this zone was a filter. It was neither part of the Asian mainland nor the Sahul supercontinent. It was a fractured series of volcanic islands surrounded by deep ocean trenches that never connected, no matter how far the ice age dropped the sea. The islands of Wallacea stayed isolated, separated by sea gaps that could only be crossed deliberately. And that matters, because the earliest evidence of our kind outside Africa tends to follow dry paths. The Levant, Arabia, India, these were places you could walk to. But to get from Southeast Asia to Australia or New Guinea, you could not walk. You had to float, or paddle, or hope, and that was the test. At its narrowest, the sea between the edge of Sunda and the rising coasts of Sahul was still over 90 kilometers wide. Depending on where you launched from, the crossing might have required 2 or even 3 separate journeys between islands, with open sea in between. This wasn't just a matter of seeing one shore and heading for it. In many places, you couldn't see the next island at all. You had to trust the wind, or birds, or some inherited memory passed through stories that have long since vanished. The most likely launch zones were places like Timor or the nearby Alor archipelago. To the west, Java and Bali remained on the Sunda Shelf, connected to mainland Asia. But east of a line now called Wallace's Line, things changed. The islands were isolated, the animals were stranger, and nothing could get there unless it could cross water. Which brings us to the real mystery. Not just that Homo sapiens did cross, but that they may not have been the first hominins to try. On the island of Flores, just west of Timor, fossils of a tiny upright species called Homo floresiensis have been found, with bones dating back as far as 700,000 years. This hobbit, as it was nicknamed, stood barely a meter tall and made stone tools, hunted pygmy elephants, and may have evolved in complete isolation from an earlier Homo erectus population that arrived from the west. The only way to get to Flores, even in the deepest Ice Age low stand, was to cross a minimum of 19 kilometers of open sea. That is not something animals do accidentally. This means someone was navigating long before we arrived. Someone without language, without charts, without fire on boats. What happened to them, we do not know. But by the time Homo sapiens reached Wallacea, they were gone. The people who came next were different. They brought fire. They brought blades that were more refined than anything Flores had seen. They brought social complexity. And perhaps most importantly, they brought others inside them. Because the humans who crossed into Wallacea did not come alone. They carried traces of DNA from a ghost species that no longer walks the earth. Denisovans. We do not know what Denisovans looked like. No complete skeleton has ever been found. Just a few teeth, a jaw, a finger bone, and now some proteins from deep inside the frozen caves of Siberia and the Himalayas. But we do know that at some point between 80,000 and 50,000 years ago, Denisovans and Homo sapiens met in Southeast Asia and interbred. This wasn't a one-time mistake. It happened enough times that the genetic legacy of Denisovans persists in many of today's populations in Papua New Guinea, Australia, and parts of island Southeast Asia. And because Denisovans never lived in Europe, their DNA in these populations is the quiet proof that humans had passed through Wallacea long before recorded history began. So what kind of vessels could make this crossing possible? There are no remains of boats from that time. Organic materials like bamboo or palm fronds do not survive for tens of thousands of years in tropical humidity. But we can infer what was possible. It's unlikely these were dugout canoes, which require sophisticated tools and large trees. More likely they were rafts, possibly made from bamboo, which grows straight, hollow, and buoyant. A well-bound bamboo raft can carry multiple people and supplies. Add a woven sail and rudder, and you have a vessel capable of steering across open ocean. The winds help too. Seasonal northwest monsoon winds blow from what is now Timor toward northern Australia, providing a natural push for rafts that might otherwise have drifted. And it's important to remember that these crossings were not made in ignorance. Wallisan Islands can often be seen from one another if you climb high enough. Smoke from wildfires or volcanic activity can also reveal land beyond the horizon. Flocks of seabirds tend to fly toward roosting zones in late afternoon. Floating vegetation or driftwood with unfamiliar seeds can hint at unseen forests. These are not myths. These are navigational cues, and they still guide indigenous seafarers today. Still, even with these cues, the challenge was enormous. For one thing, each crossing had to be intentional. You could not simply be blown off course and end up in Sahul. Every attempt had to be prepared, supplied, and coordinated. That implies social organization. A group of people trusting one another, trusting someone to lead them into the unknown. Maybe not once, maybe again and again. Which raises another haunting question. How many boats never arrived? We often speak only of success, but the history of exploration is written in silence too, in the boats that vanished, the families that left and were never seen again. There may have been generations of attempted crossings before one finally made it. And yet, we know it happened. Because the next time the fossil and genetic record speaks, we are no longer in Wallacea. We are standing on the edge of a supercontinent that would one day be flooded into islands, a place called Sahul. And it is important to pause here, because it's tempting to treat this moment as inevitable, that humans would always have gotten to Sahul eventually. But that is not how it works. Other animals did not cross, not the tigers of Java, not the elephants of Sumatra, not even Homo erectus, despite living in Southeast Asia for over 1 million years. Sahul stayed empty of hominins until this precise chapter of the Ice Age, which means the arrival of Homo sapiens was not a continuation. It was a rupture, the breaking of a line that had held for more than 1 million years, and the beginning of one of the strangest and most isolated human journeys on Earth. We do not know how many people made the crossing. Genetic models suggest the founding population of Sahul may have been in the hundreds, perhaps more. That is not a single canoe. That is waves of movement, sustained over time. The people who made this crossing were likely part of a broader migration out of Asia that spread eastward through island Southeast Asia in pulses, shaped by climate, by population pressure, by curiosity or need. And while the exact entry point into Sahul remains debated, the logic of sea currents and wind patterns points toward the northern coast of what is now Australia. But we are not there yet. That is another part of the story. For now, we are still in the water, somewhere between the volcanic islands of Wallacea and the distant sound of new birdsong over a tree line no one has seen before. We are not yet sure what lies beyond this blue, but we are paddling toward it, quietly, as the sky turns orange and the map runs out of ink. So the question that lingers is this: why now? Why did the crossing happen between 70,000 and 60,000 years ago and not earlier? If hominins had been in Southeast Asia for hundreds of thousands of years, why did this leap not happen until Homo sapiens arrived? Maybe it was a convergence of conditions, a cooling climate which lowered the seas and brought islands closer together, a new suite of cognitive abilities including language, long-term planning, and the ability to organize travel across generations. Or maybe it was something else, a pressure to leave, or a pull to explore, something we cannot measure in bones or genomes, just a trace of restlessness that crept into our cells and never left. Whatever it was, the moment they landed, the world changed, and the sea behind them did what it always does. It kept the memory quiet. Until we asked. The strange thing is, they must have known it was there before they ever saw it. Not Australia exactly. No one had that word. Not Sahul either. That is a modern reconstruction. But something. A presence just beyond the edge of visible land. Something larger than an island. Big enough to make the clouds change shape. Big enough to send birds flying the same direction every morning. Big enough to glow faintly on the horizon when the sun caught its high ground. The sea didn't give up its secrets easily, but it whispered them, and somehow humans learned to listen. It's one of the great underappreciated puzzles of human prehistory, not just how people got to Sahul, but how they knew to go at all. From the islands of Timor, Flores, or Allure, you cannot see the Australian coast with the naked eye. There is no moment when a new landmass reveals itself in full, and the distances involved, ranging from 50 to 100 kilometers of open ocean, mean that no one could have simply drifted across by accident and brought back the news. So how did they know there was something out there worth aiming for? What we're looking at here is not only the first maritime crossing of its scale, it may also be the first known use of open ocean wayfinding. That means interpreting environmental signals and making decisions based on invisible geography. The kind of navigation that, tens of thousands of years later, would allow Polynesians to reach the most remote islands in the Pacific. But this wasn't Polynesia. These were people without compasses, without metal, without maps, and still, they were able to piece together a mental model of the ocean's secrets. Start with the birds. Some seabirds, particularly frigate birds and boobies, make predictable migrations between roosting sites. They leave their island colonies at dawn and return by dusk. If you watch the sky long enough, you will see them rise in a consistent direction, disappearing into the haze. That movement hints at land. Not necessarily visible, but reachable. These birds rarely sleep on the open sea. They need a place to perch. And if you trust them long enough and paddle where they fly, you might find it. Then there are clouds. This is less obvious to us now, in a world of satellite weather. But for people who lived in constant contact with the sky, certain patterns were readable. Islands and large landmasses generate their own cloud formations. Moist air rises when it hits warm coastal terrain, condensing into distinctive cumulus stacks above unseen shorelines. These cloud domes can linger even when the land beneath is over the horizon, and they tend to sit still, unlike the moving patchwork of sky elsewhere. If you see a cloud that doesn't move, you might begin to wonder what holds it there. There is also driftwood, seeds that don't grow on your island, pumice stones from distant volcanoes, the remains of birds or fish unfamiliar to your coast. These floaters hint at another ecology, something sending objects across the sea toward you. And if things come to you, they must come from somewhere. The logic is quiet, but cumulative. And finally, there is fire, or more precisely, smoke. There are accounts from the early colonial period in Australia, some from as recently as the 19th century, where sailors reported seeing smoke columns from Aboriginal fires over the coast long before they saw land. In an age before modern pollution, smoke could carry a long way, especially from grassland or woodland fires. If this same phenomenon held true 60,000 years ago, it's plausible that explorers in Wallacea glimpsed these wisps on the horizon. Faint, vertical, too straight to be cloud. Perhaps a signal, perhaps an accident. Either way, it would have been the one unnatural thing in a natural landscape. And for people who noticed everything, that would be enough. None of these cues proves that any one group had full knowledge of what lay ahead, but together they form a pattern of reasoning, a pre-literate hypothesis. You could even call it science, in the oldest sense of the word, a process of observation and inference. People who had never seen Sahul may still have known it was there. They did not sail blindly. They sailed into probability. We often imagine prehistoric humans as reactive, moving only when pushed by climate, by hunger, by conflict. But there's a strong case to be made that the first Australians were proactive explorers, that they were not fleeing anything, but seeking, that they paddled out not because they had to, but because they could. That is a very different vision of who they were. Of course, we cannot interview them. We can only work backward from what remains. And here, the archaeology grows frustratingly thin. Much of the evidence for this earliest phase of Sahul's human history is missing. That is not because it didn't exist. It is because sea levels have since risen by more than 100 meters, drowning most of the coastal plains where people would have first arrived. The best landing sites are now ocean floor. Any camps, fire pits, or stone tools left behind are likely buried beneath mud, unreachable by current excavation methods. This makes it hard to prove anything definitively about the first contact with the continent, but it doesn't mean we know nothing. The most famous archaeological site linked to the earliest human presence in Sahul is Madjed Bebe, a rock shelter in Arnhem Land in the far north of what is now Australia. Excavations at this site have revealed stone tools, grinding stones, ochre fragments, and other cultural materials in layers that date back to approximately 65,000 years ago. These dates, published in the journal Nature in the year 2017, were challenged at first. But the research team used multiple techniques, including optically stimulated luminescence, to build their case. If the dates are accurate, and many now accept that they are, then Madjed Bebe represents the oldest known evidence of human occupation in Sahul, and it sits hundreds of kilometers inland from the likely coastal arrival points. Which raises another question. If people were already inland by 65,000 years ago, how much earlier did they actually arrive? How long did it take to move south from the coast, build communities, and leave behind durable evidence? The answer is unknowable, but the gap hints at a deeper history still waiting beneath the waves. This is where genetics comes in. Studies of mitochondrial DNA in modern Aboriginal Australian populations, as well as in ancient remains where preservation allows, suggest a founding population entered Sahul somewhere between 65,000 and 50,000 years ago. This matches the archaeological data and supports a single early migration followed by long periods of regional diversification. Unlike Europe, where multiple waves of Homo sapiens and Neanderthal interactions blur the record, Sahul shows signs of early entry and deep continuity. People arrived, and they stayed. Some of the clearest echoes of this early settlement come not from northern Australia, but from a dry, wind-scoured basin far to the south, Lake Mungo. Today, Lake Mungo is a flat, silent expanse, a dried-out remnant of a once thriving lake system in western New South Wales. But tens of thousands of years ago, it was alive with freshwater fish, bird life, and human activity. It is here that two of the most famous early human remains in Australia were found, Mungo Man and Mungo Woman. The cremated remains of Mungo Woman date to around 42,000 years ago and represent the earliest known ritual cremation in the world. Mungo Man was buried with red ochre and placed on his side, hands folded in a pose that suggests cultural depth. While the exact dates for Mungo Man have been debated, ranging from 26,000 to 60,000 years, the consensus today leans toward the same ballpark as Majed Baby, approximately 40 to 45,000 years ago. These remains show us that the people who had crossed from Wallacea were not just surviving, they were adapting, creating symbolic systems, honoring the dead, inventing new ways of being human in a land that had never seen our kind before. But here's the deeper mystery. There is no hard evidence that anyone else ever made it. No Homo erectus, no Neanderthals, no pre-sapiens hominins of any kind. Despite hundreds of thousands of years of human evolution in Asia, only Homo sapiens crossed that final threshold into Sahul. Something about this species, about us, allowed for that leap. Was it cognitive flexibility, linguistic innovation, social trust, or something simpler, like an accumulation of tiny maritime experiments finally reaching critical mass? We don't know, and we may never know. What we have instead are traces. A toolkit buried in sand, a pattern in the genes, a line of birds in the sky that told someone, somewhere, that there was more to the world than they had seen. So the real story here is not just the crossing, it's the seeing, the act of imagining a land that could not be directly perceived, of trusting indirect signs, of using what the ocean gave, clouds, birds, driftwood, smoke, to paint a picture of something real but unreachable. That is not mythology, that is inference, that is science, and it happened long before science had a name. There is a kind of intelligence here that we still do not fully understand, and perhaps never will. But it is part of us. It brought us across the sea, and it made us see what wasn't visible. And that might be the most human thing of all. It probably didn't feel like a moment that would change the continent. It likely felt more like a mistake, or maybe a relief. Salt-crusted lips, legs half numb from hours of balancing on a dugout beam, paddles dripping, eyes squinting through the sun's glare as a low strip of green finally, unmistakably, met the shore. They had arrived. But where exactly was not something anyone could name. There were no maps, no flags, no announcements, just wet sand, a new sky, and the heavy silence of a place that had never heard a human voice before. This is one of those turning points in human history that leaves no diary, no sculpture, no inscription to tell us what happened. But something did. Because somewhere between 60,000 and 50,000 years ago, Homo sapiens crossed the sea from what is now Timor, or perhaps the Alor or Tanimbar Islands, and made landfall on the northern edge of the Sahul continent. And with that landing, one of the last uninhabited continents on Earth was no longer alone. Exactly how they got there is still debated, but it was no accident. The sea between Wallacea and Sahul is not gentle. Even at the lowest sea levels of the Pleistocene, the water never disappeared. The Arafura and Timor trenches remained deep, wide barriers. The journey required multiple open water crossings, possibly of up to 90 kilometers at a time. This means no one could have simply drifted over. The people who made it must have set out with purpose, with boats capable of carrying families or clans, and with some idea, however vague, of what lay ahead. The boats themselves remain hypothetical. Organic materials rarely survive tens of thousands of years in tropical environments, and so far, no intact vessels have been recovered from this early period. But experimental reconstructions and ethnographic parallels offer some clues. Bamboo, lashed together and sealed with resins, can produce surprisingly buoyant rafts. Dugout canoes, carved from tree trunks with fire and stone tools, may also have existed. What matters is not the exact form, but the function. These were seaworthy craft, stable enough to carry groups across unpredictable ocean currents, and light enough to be maneuvered through island chains. And then there were the winds. The monsoonal systems of northern Australia and the eastern Indonesian archipelago shift with the seasons. During the northwest monsoon, strong winds blow from Asia toward Sahul. These same winds may have helped propel early seafarers toward the unknown coastline. If timed correctly, a crossing that would have been nearly impossible in one season became much more feasible in another. And once one group made it across and survived, word, or memory, could spread. Still, the land they found would have been unfamiliar. Today, when we think of northern Australia, we picture dusty outback plains or tropical wetlands. But 60,000 years ago, the northern coastal belt was a mosaic of savannas, woodlands, and freshwater channels. Sea levels were more than 100 meters lower than today, exposing wide continental shelves. What is now the Arafura Sea was a vast, open plain. Rivers flowed across it, supporting herds of giant marsupials and flightless birds. The first humans would have encountered not a narrow coast, but a great expanse, fertile, wild, and full of animal signs they had never seen before. We don't know what they called the first place they landed. We never will. But based on the genetic evidence, many researchers believe the earliest successful landing likely happened somewhere near modern-day Arnhem Land. The region's ecology, its proximity to island routes, and the richness of its archaeological record all point to it being one of the oldest continually occupied parts of Australia. The story from here branches into two streams. One follows the bodies, the other follows the tools. Let's start with the tools. At rock shelters like Madjed Baby, archaeologists have uncovered stone flakes, grinding stones, ochre crayons, and what appear to be used anvils, all embedded in layers dated to between 65,000 and 50,000 years ago. These are not random scatterings. They suggest repeated use, intentional manufacturing, and a clear understanding of the local raw materials. In some layers, archaeologists found residues of plant starch on grinding stones, pointing to the early processing of wild tubers and seeds. In others, tiny ochre particles embedded in flakes suggest the pigment was being ground or prepared for symbolic use. Whether for body decoration, ritual marking, or some other cultural function, ochre is one of the oldest signs that humans were doing more than surviving. They were creating meaning. The other stream, bodies, is harder to follow. Organic remains are rare in tropical climates. Bones decay, teeth break down. But what does survive very faintly is genetic continuity. Studies of mitochondrial DNA from modern Aboriginal Australians show extremely deep lineages, diverging from all other non-African populations somewhere around 65,000 years ago. This makes Aboriginal Australians one of the oldest continuous populations outside Africa. The genetic signal supports a scenario in which a relatively small founding population entered Sahul early and then diversified regionally, adapting to a vast new continent with extreme ecological variety. And yet, even with these breakthroughs, we still cannot name the first individual who landed. We cannot point to a skeleton and say, this was the one. The landing itself remains anonymous. But we can imagine. A child's first footprint in wet sand. A fire started with kindling gathered from alien trees. A strange cry in the night from an animal no one had ever heard. The smell of new soil. The patterns of stars in a sky free from city light, looked upon with awe and no story yet to hold them. These people were not just biological humans. They were cultural innovators. The arrival of Homo sapiens in Sahul marks not only the spread of a species, but the beginning of an entirely new chapter in symbolic thought. This becomes even clearer when we consider ochre. Ochre use in northern Australia goes back to at least 50,000 years ago, based on layers at sites like Nawalabila and Madjed Baby. In some cases, the ochre appears to have been worked with stone tools. In others, it seems to have been used directly on surfaces, possibly the earliest stages of what would evolve into a rock art tradition, unmatched in its depth and duration anywhere in the world. While the oldest confirmed rock art in Australia is much more recent, the presence of ochre this early suggests the foundation was already in place. The mind that would one day draw kangaroos on cave walls was already seeing the world in images. What this tells us is that symbolic thinking arrived in Sahul not as a gradual local development, but fully formed. It came ashore with the first paddles and footprints, and it never left. That raises a difficult question. how much of what was brought ashore has been lost? With sea levels now more than 100 meters higher than they were during the early occupation of Sahul, most of the initial landing zones are now underwater. The ancient coastlines, where people likely made camp, buried their dead, or carved the first marks into stone, are now marine archaeology sites, unreachable to most tools, invisible to the eye. Every decade or so, a storm or a dredge brings something new to light, a worked stone, a fragment of ochre, but the big discoveries remain elusive. What we do know is that once they landed, people spread, rapidly. Within a few thousand years of arrival, human populations were moving inland, following river valleys, adapting to dry plains and cold uplands. The speed of this spread suggests high adaptability, group cooperation, and strong knowledge transfer. It also suggests that the first landing was not a trickle. It was a founding wave, large enough to establish viable populations, diverse enough to adapt to a dozen new ecologies, and stable enough to persist for tens of thousands of years. But back at the coast, on that first day, they didn't know that. They just knew they had landed. No one would have called it an achievement. There was no banner, no chronicle, just a new beach, a new dawn, and the beginning of the longest continuous human story on any continent on Earth. What is haunting is not what we know, it's how much we can never recover. The first song sung on that shore is gone. The first name given to a new tree, lost. The first story told by firelight, swallowed by the silence of time. But the footprints, even if washed away, led forward. And somewhere in those first steps is the memory of what it means to begin again. It is strange to say, but the oldest sign that someone once lived here is not a skeleton. It is not a word. It is not even a tool. It is a color, deep, earthy, and rust red. It comes from a mineral that forms when iron oxidizes in the ground. Crushed and powdered, it becomes ochre, and when smeared on rock, skin, or stone, it becomes memory. The site that gives us the clearest glimpse into this ancient memory is Madjed Bebe, a rock shelter tucked into the stone country of Arnhem Land in northern Australia. It is here, among the crumbling sandstone escarpments and monsoonal woodlands, that archaeologists have found the earliest physical evidence of human presence anywhere on the Australian continent. Not footprints, not bones, but flecks of ochre, stone flakes, and grinding stones, all buried in the earth, some of them layered more than 2 meters deep beneath the shelter floor. When first excavated in the 1970s, Madjed Bebe was already known to be old, but it was only in recent decades, with refined dating techniques like optically stimulated luminescence, that its full antiquity came into view. The lowest occupation layers at Madjed Bebe have now been dated to around 65,000 years ago, though most researchers place the most confident earliest human activity somewhere between 50,000 and 55,000 years ago. That alone would be remarkable. But what makes this site so important is not just its age, it is its complexity. In the deepest levels, archaeologists found over 10,000 artifacts, including edge-ground hatchets, flaked stone tools, plant processing equipment, and the oldest known use of ground ochre in Australia. Some pieces were clearly used to crush or rub pigment. Others bear traces of mica and silicates, materials that suggest not only utilitarian function but symbolic behavior, decoration, marking, or ritual. This is not the toolkit of a wandering band. It is the footprint of a people who stayed long enough to build knowledge, express identity, and pass it down. One of the ochre pieces found at Madjed Bebe was incised with deliberate cross-hatching. It is a small artifact, easy to overlook, but it may be the earliest surviving mark made by a human on the Australian continent. It is not a sentence, not a story, but it is a decision, a gesture, a line etched into the fabric of deep time that says, "I was here, and I left a mark." The implications of this are hard to overstate. It tells us that the first Australians were not merely surviving, they were symbolically aware. They were using color to alter surfaces, perhaps their bodies, perhaps the stone walls of the shelter. And this was not a late development. Symbolic behavior was there from the beginning. It arrived with the people themselves. The use of ochre in early Homo sapiens populations is widespread across the globe, but the forms it takes are always shaped by local meaning. In some cultures, ochre was applied to the dead during burial. In others, it was smeared on bodies during rites of passage, or mixed into paints for rock art. We do not know precisely how ochre was used at Majed Baby, but we do know that it was worked, carried, and selected, sometimes transported from distances far outside the local stone catchment. That suggests preference, value, and that, in turn, suggests culture. To understand how significant this is, we need to place Majid Bebe in a global context. At around the same time as these early Australians were crushing ochre and shaping axes in the stone shelter, other Homo sapiens groups in Africa were carving ostrich eggshell beads and painting geometric motifs on cave walls. In Europe, it would still be tens of thousands of years before symbolic art appeared in the archaeological record. In short, what we find at Majid Bebe places the earliest Australians among the world's oldest known creators of abstract symbolic material culture, and they did it far from the centers of population on a continent that no other hominin had reached before. That raises a question. If they were already expressing culture in ochre, where are the oldest paintings? The answer, frustratingly, lies in preservation. Australia's tropical north is not gentle on pigments. Moisture, lichen, and chemical weathering degrade rock surfaces over time. Many early artworks may simply have vanished. What we do find today are later layers, ghostly figures, hand stencils, and radiating lines that span tens of thousands of years. But there is a growing suspicion that the tradition began much earlier. The ochre at Majid Bebe hints at a lost archive, painted in red, now dissolved into dust. The site also reveals another layer of complexity, landscape knowledge. To live in the stone country of Arnhem Land is to know its rhythms. This is not a forgiving place. The climate swings between scorching dry seasons and floods that isolate entire plateaus. To survive here requires knowledge of water sources, plant cycles, and animal behavior. The people who return to Majid Bebe year after year seem to have understood these rhythms. Their toolkits shift slightly through time, but the continuity of occupation speaks to a long-standing relationship with place. This was not a temporary camp. It was a home, repeatedly reoccupied, remembered, and reused across millennia. But perhaps the most humbling part of this story is what we cannot find. Despite all the stone and ochre, the bones of the people themselves are missing. So far, no human remains have been found in the deepest layers of Majid Bebe. That leaves us with silence where we most want a voice. We do not know how tall they were, what they looked like, or what ailments they carried. But in a way, their absence is its own kind of presence. It reminds us that archaeology is always a partial story, a flicker, a shadow, a science that stitches together fragments into a tapestry we know can never be whole. And yet we keep trying. What makes this story uniquely Australian is that it is not just a scientific reconstruction, it is also a living memory. For the Marar people, the traditional custodians of the land on which Majid Bebe sits, this is not a site of ancient strangers. It is part of their ongoing cultural heritage. Oral traditions, dreaming stories, and custodial knowledge form a continuous thread between the past and present. In this view, the people who left those ochre marks are not forgotten ancestors. They are remembered ones, and their memory lives on not in museums, but in song lines, kinship systems, and landscape ties that still bind communities today. This convergence of scientific and cultural time is rare. Too often, ancient archaeology is treated as if it belongs to no one. But at Majid Bebe, every excavation is done in partnership with the Mirar. Every interpretation is shaped by dialogue, and every artifact, no matter how small, is a reminder that history is not just something we uncover, it is something we must respect. Still, the scientific question remains. What exactly was the earliest sign that someone lived here? If we define sign as material evidence, then it is the ochre, the flakes, the grinding stones. If we define it more broadly, as proof of symbolic behavior, then it is that tiny, etched crosshatch. But perhaps the oldest sign is not an object at all. Perhaps it is the act itself, the choice to stay in a place long enough to leave a record, the decision to return again and again to the same stone shelter, building up layers of ash, pigment, and memory. The moment when survival became culture and movement became meaning. What survives is fragmentary, but what it tells us is clear. The first Australians did not merely arrive. They created, they marked, they remembered. And in those marks, we find not answers, but echoes. A red line in stone, a flake shaped by hand, a silence filled with memory, and the haunting question that always remains: how many other stories, older still, have already crumbled back into the earth? It did not take long, at least not in the way we once imagined. For decades, researchers assumed that the first humans who entered Sahul would have needed thousands of years to inch across its massive interior. But the pattern emerging from the archaeological record tells a different story, a faster one. Within just a few millennia of first landfall on the northern edge of the continent, Homo sapiens were already leaving signs of their presence deep in the deserts, along the coasts, and across the river systems of what we now call Australia. Somehow, without wheels, roads, or written maps, these early foragers had covered almost all ecological zones on the continent. And they had done it during a time when the animals were bigger, the climates harsher, and the land entirely unknown. The question is not whether humans spread quickly across Sahul. The question is how fast, and how much of the land they changed in the process. By around 50,000 years ago, archaeological traces begin appearing not just along the northern coast where the first landfalls likely occurred, but in areas as far apart as the Flinders Ranges in South Australia and the Upper Swan region of Western Australia. These are not isolated anomalies. They are part of a growing constellation of site dates that suggest a continental diffusion of Homo sapiens across more than 7 million square kilometers in just a few thousand years. Some estimates propose that humans reached southern Australia as early as 48,000 years ago. Central arid zones show occupation soon after. From a modern perspective, this is hard to grasp. The distances involved are vast. The environments range from monsoon forests to salt flats to mountain ridges to semi-arid steppe. And yet, the evidence suggests that the spread was not a slow drift. It was deliberate, adaptable, and fast. How fast is still debated. Some computer modeling studies suggest that with even modest population growth and movement rates, a small founding population could have expanded across the continent in less than 1,500 years. That's a blink in archaeological terms. Other models, incorporating known site dates and ecological constraints, propose a slightly slower but still rapid expansion over 2,000 to 4,000 years. What's striking is not the speed itself, but the flexibility it required. Humans entering Sahul had no experience with Australian flora and fauna. They had never seen a kangaroo, never tasted a yam daisy, never felt the heat of the central desert wind. Every tool, every strategy, every route had to be adapted in real time. But the archaeological pattern shows that they did adapt, and quickly. What allowed for this remarkable spread was not a single innovation or lucky climate window. It was a pattern of ecological intelligence. These early humans were not just wandering. They were reading the land. In places like Devil's Lair in southwestern Australia, charcoal deposits and stone tools suggest occupation by at least 48,000 years ago. In the Flinders Ranges, red ochre and burnt plant remains indicate similar timelines. These sites are separated by more than 3,000 kilometers of varied terrain. That kind of distribution suggests more than just exploration. It implies permanent settlement and ongoing movement within and between regions. One of the most surprising elements of this diffusion is what it reveals about human engagement with fire. Across much of the continent, especially in the central and western regions, charcoal layers begin to appear in sediment profiles shortly after human arrival. These are not from natural lightning strikes. They are controlled burns, landscape fires set by humans to manage vegetation, attract grazing animals, or clear pathways. In some areas, such as the Arnhem Plateau and the Western Desert, these burn patterns coincide almost perfectly with the earliest archaeological traces of human presence. This is not unique to Australia. Fire management is one of the oldest human ecological strategies, but in Sahul, it may have played a particularly crucial role. Fire opened up closed forest canopies, promoted the growth of fire-tolerant grasses, and created a patchwork of habitats that could support more game. In effect, fire became a tool of mobility. That mobility extended even into the deserts. The central regions of Sahul, including what is now the Simpson and Great Victoria deserts, were not barren wastelands during the Pleistocene. They were challenging, yes, but also dynamic and seasonally rich. Archaeological sites such as Purit Jara in the Northern Territory and sites near Lake Eyre show occupation dating to over 40,000 years ago. These are not accidents. People lived, moved, and likely returned to these places over generations. The tools found here are often simple: flakes, scrapers, hammerstones, but they speak to a rhythm of life adapted to scarcity. In the desert, the key was knowing when and where water would appear, which plants would fruit after rain, and how to read the tracks of animals over dunes. Knowledge like that is not guessed, it is accumulated, which means these were not just passers-by, these were residents. What we do not find, interestingly, is any single technological breakthrough driving the expansion. Unlike in some other regions of the world, there is little evidence of revolutionary new tools appearing at the moment of continental colonization. Instead, the toolkit remains largely consistent with earlier Southeast Asian assemblages: flakes, cores, points. There is some regional variation, of course, but overall the emphasis seems to have been on flexibility, not specialization. What does appear to change is the intensity of site use. By the mid-40,000s, we begin to see denser occupation layers, more extensive fire residues, and more widespread tool discard. All of this suggests growing populations and increasingly complex interactions with the environment. Water sources were almost certainly the key constraint on how and where people moved. In the arid interior, occupation sites tend to cluster around springs, rock holes, and paleo lake beds. Seasonal mobility may have followed a pattern of pulse and retreat, moving into the desert after rains, withdrawing when the land dried out. This mobility also influenced how knowledge was stored and transmitted. In a landscape with few permanent landmarks, memory and oral transmission became essential. It is here that songlines, long oral narratives tied to geography, may have begun to form. While we cannot directly trace these back to the Pleistocene, many researchers believe that some of the most ancient songlines encode routes that have been traveled for tens of thousands of years. If true, this would mean that cultural memory itself became part of the navigational toolkit. One of the biggest puzzles in this story is the sheer number of sites showing early occupation, despite the challenges of preservation. Much of the oldest coastline has been lost to rising seas, meaning the first landing sites are likely underwater. Yet even with that loss, dozens of inland and upland sites confirm that humans were present across all major ecological zones by at least 40,000 years ago. This includes the tropical north, the temperate south, and the arid heart. In Tasmania, separated by a land bridge at the time, humans were present by at least 38,000 years ago. Again, the speed and extent of this diffusion are hard to overstate. What this tells us is that the story of human arrival in Australia is not just a story of boats and crossings. It is a story of one of the most successful terrestrial adaptations in human history. Within a few thousand years of arriving, Homo sapiens had become an ecological force across the entire continent. They were burning landscapes, altering vegetation patterns, adapting to drought, learning new species, and creating knowledge systems to pass on what they learned. And they were doing this with stone tools, fire, and memory. There are still many things we do not know. We do not know exactly how many people made that first crossing, or how many waves of migration followed. We do not know which routes were favored, which groups split off, or how they communicated across such great distances. We do not know what kinds of social structures guided these movements, or how often people returned to the same places year after year. But what we do know is that by 40,000 years ago, humans had become an inseparable part of the Australian landscape. They were not visitors anymore. They were home. And yet, that invites a question. How does a species come to belong somewhere it has never been before? Is it by staying? By changing the land? By telling stories that turn space into memory? However it happened, by the time the Ice Age deepened, Australia was no longer an untouched wilderness. It was already a human continent, thick with fire, tracks, and the first long arcs of memory carved into the land. If you had arrived on the shores of northern Australia 50,000 years ago, the sea would have been far away. What we now call the coastline didn't exist. In its place were plains, river valleys, and forests that extended hundreds of kilometers beyond today's beaches. These were the first lands seen by the early arrivals to Sahul, and they are gone. The ocean rose, and it took the map with it. This is a story about what we lost to the sea, but it's also a story about how absence itself leaves clues, and why the deepest mysteries of early human Australia now lie beneath the waves. At the height of the last ice age, Much of the world's water was frozen in the great polar ice sheets. This locked up massive volumes of seawater, dropping global sea levels by over 100 meters compared to the present. In the southern hemisphere, this had a striking consequence. It merged the landmasses of Australia, New Guinea, and Tasmania into a single continent known as Sahul. It stretched from the Arafura Sea in the north to the cool forests of the far south, bound not by water but by dry land, and ringed with a coastline that no longer exists. The first humans to reach this continent would have encountered an Australia we cannot fully imagine, not just climatically different, but geographically unfamiliar, with ecosystems that disappeared along with the lost lands that once supported them. So where are the oldest campsites? Where are the first settlements, the canoes dragged ashore, the ashes of the first fires lit on Sahul? The honest answer is, we don't know, and we may never know. The earliest human arrival in Australia almost certainly took place near the coast, but the archaeological evidence of that event is now submerged. The coastal plains that once connected Sahul's islands and hosted its first inhabitants have been drowned by the post-glacial sea level rise that began around 20,000 years ago and accelerated rapidly after 16,000. By the time the climate stabilized 10,000 years ago, more than 2 million square kilometers of coastal shelf had vanished beneath the Pacific and Indian Oceans. That includes the original landing zones and likely the earliest evidence of human life anywhere in the continent. Archaeologists call these now submerged sites drowned landscapes, and recovering them is one of the great technological frontiers in global prehistory. But Australia presents particular challenges. Unlike regions like the North Sea, where trawling and oil exploration have accidentally recovered Mesolithic artifacts, the submerged shelf around Sahul is vast, remote, and relatively undisturbed. It lacks the sediment traps that might preserve organic material for millennia, and the logistics of deep-sea survey work are complex and costly. In short, the sea has not only hidden these early coastal sites, it has made them nearly unreachable. We are trying to reconstruct the lives of a people whose first memories, first shelters, and first coastlines are now out of reach, both geographically and archaeologically. Still, absence leaves traces. If we cannot yet find the coastal sites themselves, we can model their locations and shape by examining the submerged topography and reconstructing paleo coastlines from satellite data, sonar mapping, and bathymetric surveys. These reconstructions show ancient river mouths now deep beneath the sea, estuaries where fresh water once flowed into brackish inlets, and high ground that likely served as campsites or lookout points. Around these long-drowned features, researchers have begun to focus their attention. In two places, off the coast of northwestern Australia in the Dampier Archipelago, actual evidence has begun to surface. At Cape Bruguieres and Flying Foam Passage, archaeologists have documented stone artifacts on the modern seabed that may date to over 7,000 years ago, before those areas were submerged. These are small, tentative signals, but they hint at what lies hidden. It is also possible that many of these early sites were not preserved at all. Much of the shelf around Australia is a high-energy environment where wave action, shifting sand, and warm currents make long-term preservation difficult. Organic materials like wood, bone, and shell tend to decay quickly in such conditions. Fire sites, middens, and even burial grounds may have been destroyed before they could fossilize. What we are left with is a selective record, biased toward inland regions that remain dry and exposed, especially sites that were later revisited and reused as humans adapted to an increasingly interior-focused lifestyle. This is why inland sites like those of western New South Wales become so important. The famous Willandra Lakes region, especially Lake Mungo, offers a rare glimpse into the deep human past that we can still access. Though far from today's coastline, these sites were once part of a vast freshwater system that supported communities living around its shores during the late Pleistocene. As the climate changed and the lakes dried out, the sands preserved the remains of these people, their fires, their meals, and in a few cases, their burials. Lake Mungo offers one of the clearest windows we have into early Australian life, not because it was the first inhabited place, but because it is one of the few that survived erosion and submersion. The loss of coastal sites also skews our understanding of migration. If the earliest arrivals island hopped their way through Wallacea and reached Sahul via the shortest sea crossings, it stands to reason that their landfall would have been on what is now northern Australia. But without coastal archaeological evidence, We can only model this process indirectly, through genetic data, ecological modeling, and comparisons with better preserved island chains. It is likely that multiple groups arrived over time, possibly in different locations, and that some failed to establish permanent communities. The survivors moved inland, following rivers and prey, adapting to unfamiliar ecosystems. But how they chose routes, how they signaled each other, how long it took to establish a foothold, all of that remains hidden beneath the waves. There is also a cultural cost to this loss. Much of Aboriginal oral tradition is deeply tied to the landscape, and some communities maintain ancestral stories of rising waters, drowned lands, and journeys across now-vanished coastal plains. These are not just metaphor, they are memory encoded in story. In recent years, researchers have begun comparing these oral histories to sea level reconstructions, and in some cases, they match with uncanny precision. Stories of land now underwater, islands that disappeared, or paths now broken by sea may preserve echoes of real geographic events that happened many thousands of years ago. If true, this would represent one of the oldest continuous cultural records of environmental change on Earth. The scientific challenge, then, is to respect the precision of that memory while acknowledging the limits of our current methods. We are building hypotheses from satellite maps and sonar blips, while some Aboriginal elders may already know, in story form, what used to be there. But even with this humility, the technical path forward is daunting. Underwater archaeology in Australia is still in its infancy, and the costs of deep-sea exploration limit how quickly we can progress. Unlike open deserts or upland lake beds, the drowned shelf does not give up its secrets easily. But those secrets matter. They contain the origin story of a continent and the memory of its first explorers. What would we find if we could lift the ocean like a curtain? Perhaps the foundations of shelters, fire-cracked stones, fish traps made of stakes and twine. Perhaps footprints preserved in once wet clay and sealed beneath layers of sand. Maybe even art, scratched into stone or smeared in ochre, that once faced the morning tide and now lies in darkness. These things, if they exist, would change our understanding not just of how humans spread through Sahul, but of how they first saw it. What they thought of this strange, dry, fire-prone landmass, whether they knew they had crossed into a new continent, whether they named it. There is a melancholy in this search. Every year the ocean takes a little more, as rising sea levels and storm surges erode the edges of what remains. Meanwhile, human infrastructure, dredging, and drilling disturb sediments that have rested untouched since the Ice Age. Time and tide are in no rush to help us, and so archaeology must find ways to see through water, through silt, through uncertainty. Every model refined, every coastal map reconstructed, is a small rebellion against the amnesia of rising seas. In the end, the question isn't just what is under the ocean. It's how much of the human story has always taken place just at the edge, between land and sea, between what we can recover and what has already slipped away. If we want to know how it began, we will have to listen not only to what the land tells us, but also to what the silence of the sea is trying to hide. The bones do not speak in words, but in silences measured by sediment. They do not confess. They endure. Between 42,000 and 10,000 years ago, the human record of the Australian continent was not kept in books or carved into durable stone monuments. It was recorded in the layering of ochre over flesh, in the position of limbs folded or outstretched in grave beds now dried into lake bed dunes, in the blunt geometry of skulls, and in the controversy sparked by their rediscovery. What they tell us, and what they refuse to confirm, continues to shape how we see the first Australians. And just as often, it reshapes how we see ourselves. One of the first ancient individuals to emerge from the silence was found in the white salt dust of Lake Mungo in southwestern New South Wales. In the year 1968, fragments of bone belonging to a small, cremated human were unearthed. The individual, later named Mungo Woman, had been burned, broken, and buried long ago in a ritual not widely attested elsewhere in the prehistoric world. Her remains, dated to around 42,000 years ago, became the earliest known cremation on Earth at the time. Then in 1974, another skeleton came to light nearby, Mungo Man. He was not burned, but buried intact, laid on his back, and dusted with red ochre. That detail matters. The presence of ochre in ancient graves is a cross-continental echo. In southern Africa, in Western Europe, and now, at the edge of Lake Mungo, This vivid red iron oxide seems to mark the threshold between life and memory. But the most striking thing about these individuals was not their burial alone, it was their age. Before this, many scholars had assumed Australia was settled far later. But Mungo Man and Mungo Woman forced a revision. Modern humans had arrived in Australia not just tens of thousands of years ago, but deeply enough in time to leave behind multiple generations of structured, symbolic culture. They were not aimless wanderers. They were embedded in place. Still, not all ancient remains matched the Mungo pattern. In the sandy ridges of northern Victoria, at a site known as Cow Swamp, excavations between the years 1968 and 1972 uncovered over 40 individuals dating between 14,000 and 9,500 years ago. Their physical characteristics were robust, and not just robust in the poetic sense, but literally, skeletally. The skulls were thicker and more massive, with pronounced brow ridges and large muscle attachment points. One individual, known as Cow Swamp 5, stood out in particular. His jaw was broad, his cranial vault long and low, and his skeletal frame powerful. This sparked an uncomfortable question. Were these individuals from a different lineage? Some researchers propose that these remains preserve traits inherited from earlier, archaic human ancestors, possibly even Homo erectus populations in Asia. Others believed the morphology reflected local adaptation, or even cultural modification. One such practice, artificial cranial deformation, was known from various indigenous Australian groups. Binding a child's head during early development can create long, sloping foreheads and flat skulls. This could explain the variation without invoking genetic difference. But as with all things in science, no single theory dominates forever. The debate is still ongoing. The Kubul Creek skeletons, found further north in New South Wales and dating to around 13,000 years ago, share many of the same robust features. Like the Cow Swamp population, they raise the same unresolved questions. Was this diversity biological, cultural, environmental, or simply misunderstood? No clear answer has yet prevailed. DNA studies might seem like the obvious path forward, but ancient genetic material degrades quickly, especially in Australia's hot and acidic soils. In the early 2000s, a team announced they had extracted mitochondrial DNA from Mungo Man and claimed it showed his lineage was distinct from all modern humans, potentially refuting the out-of-Africa theory. But follow-up analyses failed to replicate the findings. Most now believe the original results were due to contamination. In more recent years, DNA from a different ancient individual in the region, known as WLH4, was successfully sequenced. This person likely lived within the last 10,000 years and fell well within the expected range of modern Aboriginal Australian genetic diversity. So if we cannot always trust DNA, we must rely on the bones themselves and on the archaeology that surrounds them. What emerges is a continent populated by people with rich variation in physical form, burial practice, and symbolic expression. Lake Mungo remains a key locus. It is a place where multiple burials, stratified deposits, and environmental change intersect. When Mungo was a lake, it supported freshwater ecosystems, fish, and human communities. But as the climate changed and the lake dried by around 18,000 years ago, people adapted or moved. Yet the bones stayed. One haunting pattern stands out. Many ancient individuals in Australia are found in elaborate or purposeful burials, indicating that the dead were remembered, not discarded. Cremation at this time is rare globally. So is the consistent use of ochre in funerary contexts. These facts suggest that symbolic thought was not a late development. It was present from the beginning. And then there is the problem of what we cannot see. For every burial uncovered inland, there may have been dozens lost along the coast, now drowned by rising seas. The inland burials endure because the land endures. But most humans live near water. It is statistically probable that the earliest burials, the earliest dead, and the most diverse range of cultural treatments of the human body are now hidden beneath the modern continental shelf. What survives is a biased sample. Still, it is a sample worth examining closely. Each body tells a different story. Some are curled tightly, knees against chest, arms drawn in, like Cow Swamp 14. Others lie straight, extended, sometimes with ochre, sometimes without. The variability hints at differing beliefs, rituals, or even cultural identities. There is no evidence for a single uniform burial practice across early Australia. This alone undermines the idea of cultural stagnation. These were not frozen traditions. They were living, breathing systems of thought, adjusting to place, climate, and social evolution. Tools found near burial sites further complicate the picture. Ground-edge axes, dated to around 48,000 years ago, have been found in northern Australia, showing a level of technological advancement ahead of what appears in Europe. This does not prove superiority. It simply proves ingenuity in response to context. The land asked different questions, and humans offered different solutions. Skeletal analysis also reveals signs of lived experience. Patterns of joint wear, spinal compression, and dental health point to the physical demands of life in Pleistocene Australia. These bodies were not abstract symbols. They belonged to individuals who hunted, gathered, traveled, made decisions, suffered injuries, and survived as long as they could. Some skulls bear trauma consistent with blunt force, but it is unclear whether these were accidents, interpersonal violence, or post-mortem taphonomic processes. We cannot know. We can only measure. And in the end, it is the measuring that defines much of this story. Every bone is measured, every date calibrated, every theory tested, abandoned, or revived. The ancient humans of Australia left no written records, but their bodies are a form of writing, a kind we are still learning to read. What they tell us is both sobering and inspiring. That diversity existed long before it was politically debated. That symbolic behavior was not a rare evolutionary trick, but a consistent feature of early Homo sapiens. That the first Australians were not primitive. They were complex, capable of cremation, ceremonial burial, symbolic pigment use, and long-distance land occupation. And yet, they are not solved. Even now, some archaeologists argue over the interpretations of the skulls at Cow Swamp. Are they a separate lineage? Are they a product of climate-driven adaptation? Are they cultural artifacts of head-shaping traditions? No definitive answer yet holds, and perhaps it never will. But maybe that is the point. The past does not owe us clarity, only a record of what once was. So we keep digging. We keep examining the bones. We keep comparing jaw angles and orbital widths and the mineral stain of ochre clinging to porous surfaces. Because one day, a new method may give us what we lack now. Until then, the ancient dead of Lake Mungo and Cow Swamp are still speaking, not in certainty, but in data. And if we listen long enough, carefully enough, the message becomes clearer. That humanity did not arrive in Australia as a finished product. It unfolded, it learned, it remembered, and in the bodies it left behind, it still remembers. That is the haunting truth. The dead are not gone, they are waiting to be understood. Imagine picking up a tool made 50,000 years ago and realizing it works. Not just works, but does the job better than anything else in the world at that time. Not in Mesopotamia, not in the Ice Age caves of France. Right here, in the ancient soils of Australia. That is the quiet revolution hidden beneath the feet of a continent. For decades, researchers believed that early human technology followed a predictable arc. Africa led the way, Europe refined it, and Australia, far on the edge of everything, simply caught up. But the evidence unearthed from ancient riverbeds and rock shelters has begun to invert that story. Some of the world's oldest ground-edge stone axes have not been found in Europe or the Near East, but on this continent. That might not sound like much unless you realize that it pushes the timeline of complex tool innovation into a period when most of the rest of the world was still napping flakes off river cobbles. The axe fragments recovered from sites such as Carpenter's Gap in the Kimberley region are not just old. They are older than any comparable technology yet found elsewhere. Dating to around 46,000 years ago, these tools were already ground smooth, hafted, and purpose-built. The grinding itself is a technological leap. It requires a level of patience and repetition, and most importantly, intent. You do not accidentally grind an axe head. You do it because the result is sharper, more durable, and more reliable. You do it because you know it matters. And someone, at least 40,000 years ago in northern Australia, had already figured that out. When similar technology appears in Europe, it will be tens of thousands of years later. Which raises the question, were these Australians ahead of their time? Or have we simply been looking in the wrong direction? What stands out most in the archaeological record across ancient Australia is not just the age of the tools, but the variation. Technological adaptation in this period is not uniform. It is regional. In some places you find backed blades, tiny slivers of stone flaked from quartzite and silkrete, shaped into delicate cutting edges. In others you find large core tools, heavy-duty implements designed for chopping and smashing. In desert regions, there is an emphasis on minimalism, tiny flake tools made from whatever was available. Near water sources, larger and more specialized kits. This suggests something fundamental. People were not simply copying the same designs. They were innovating based on their environment, adapting to local conditions, rethinking the shape of their tools based on the landscape in front of them. And that kind of responsiveness is arguably more impressive than any single invention. There is a temptation in the modern mind to treat tools as passive objects, dead stones in a museum case. But to the people who made them, they were anything but dead. These objects were the interface between human cognition and survival. Every flake struck from a core was a decision. Every edge shaped and sharpened was a memory, passed from one hand to the next. What we call a toolkit was, in reality, a repository of culture. A form of knowledge storage that predates writing by tens of thousands of years. The fact that this knowledge was transmitted orally, through demonstration, makes it even more remarkable. There are no instruction manuals, just eyes, hands, and time. One of the oldest technologies discovered in Australia is the use of edge-ground axes, but it was not the only innovation. The presence of grinding stones, used to process plant material, suggests a deep understanding of edible resources. Some of these stones show evidence of repeated use, with microscopic analysis revealing traces of starchy plant matter, seeds, roots, tubers. At Cuddy Springs, tools have been found in direct association with megafaunal remains. Though the debate continues about whether this proves direct interaction, the tools themselves speak of a broader spectrum of activity than simple hunting. People were modifying their environment, harvesting, processing, storing. In the arid zones, the spread of seed-grinding technology suggests an early response to fluctuating climates. When hunting became less reliable, plant resources offered stability. But unlocking those calories required ingenuity. Grinding seeds is not intuitive. It is tedious and labor-intensive. You have to know which plants are worth the effort, how to prepare them to neutralize toxins, how to build up the muscle memory to do it day after day. This was not random behavior. It was systematic, and it was effective. Another remarkable adaptation was the use of composite tools, that is, tools made by combining multiple materials. A stone blade is embedded into a wooden handle, often using plant resin as an adhesive. The resin itself is complex to produce. You need the right trees, the right temperature, and a controlled fire. This kind of multi-part construction speaks volumes about cognitive capacity. It shows planning, abstraction, and trial and error learning. In some sites, the residue of Spinifex resin has been recovered, hardened into glossy black lumps that once secured cutting edges in place. In others, beeswax was used, an even rarer and more delicate material. These adhesives are some of the earliest examples of synthetic chemistry in the archaeological record. In tropical regions, the toolkit changes again. Here, the humidity and rapid decay of organic material makes preservation difficult. But even so, evidence suggests the use of bamboo in tool manufacture. Bamboo, unlike stone, does not fossilize easily. But experiments in ethnoarchaeology, working with indigenous communities who still use bamboo tools, help fill in the blanks. The properties of bamboo make it ideal for certain tasks: cutting, fishing, even fire-making. That such tools do not appear in the traditional stone record is not a failure of innovation. It is a blind spot in our methods. All of this suggests that the technological landscape of early Australia was not static. It was dynamic, experimental, and deeply local. From edge-ground axes to resin-hafted blades, from grinding stones to invisible bamboo knives, the continent was alive with invention. And yet, much of it remains under-recognized. Perhaps because it does not fit our preconceived timeline of progress. Perhaps because it happened outside the familiar centers of European prehistory. But the pattern is clear. Innovation was never centralized. It was global. And in Australia, it was thriving. So were early Australians ahead of Europe in technology? That is the wrong question. The more useful question is, why do we keep acting surprised? These were people with the same cognitive capacities as anyone else on the planet. Their tools reflect deep adaptation, local knowledge, and creative problem solving. They were not waiting for civilization to arrive, they were already shaping it. As always, our view is incomplete. Organic tools rarely survive. Dating methods have margins of error, and new discoveries continue to push the story further back. But what is already clear is this. The first Australians were not technological latecomers. They were pioneers in their own right, not just surviving, but thriving, and doing it with tools that, in many cases, were ahead of their time. What else have we missed in the global record? What tools, what techniques, what clever adaptations now lie beneath the sands, eroded or forgotten? And what does that say about how we measure intelligence, progress, or innovation across cultures? Perhaps the real mistake is assuming that prehistory moved in one direction, that some people were advanced and others behind, when the evidence, quietly waiting in the soil, tells a different story entirely. If all of Australia's early human history vanished in a flood tomorrow, if every hearth, every flake of stone, every grave, and every bone dissolved back into the soil, there is a chance the land itself would still remember. It would remember in ochre, in layered, looping pigment, in ghost shapes painted on stone walls in places so remote that only bats and time can hear the silence around them. Because somehow, out of all the tools early humans left behind, the one that has survived the longest is not a knife or a net. It is the story, not spoken, not carved, painted, over and over. And no other continent has quite the same archive. The oldest surviving rock art in Australia might go back as far as 30,000 years ago, though exact dates are slippery. In parts of Arnhem Land, the Kimberley, and Cape York, galleries of paintings stretch across escarpments and caves that have watched the seasons turn for more than 1,000 generations. What is astonishing is not just the age of these images, but their continuity. We do not just see that humans lived here long ago. We see how their understanding of life evolved, how their relationship to the landscape was not just practical, but spiritual, layered, and observational. In other words, what these artworks preserve is not just imagery, they preserve memory, and the act of remembering itself. Let's start with the basics. In the Kimberley region of northwestern Australia, the famed Gwion figures, once known as Bradshaw paintings, offer a haunting glimpse into a vanished artistic era. They are elegant, elongated forms, often painted in red ochre with intricate headdresses, waistbands, and boomerangs. They do not resemble the more recent X-ray style art, which focuses on internal organs and animals, nor do they mimic modern Aboriginal styles in the immediate region. Instead, these figures appear to belong to a visual system that may have drifted into extinction. Estimates based on mineral accretions and stratigraphy suggest some Gwion images are between 12,000 and 17,000 years old, though some researchers argue they could be older. And if so, these aren't just decorations. They are echoes of an entire symbolic worldview, one that we no longer fully understand. Elsewhere, the rock art of Arnhem Land tells a slightly different story. Here, the imagery spans an enormous time frame and includes everything from hand stencils and animals to intricate depictions of the rainbow serpent and dreaming figures. The famous site of Nawarla Gabarnmong, a rock shelter in the Jawoyn lands of the Northern Territory, features paintings dated to at least 28,000 years ago, not just single works but layered sequences of pigment, suggesting that these caves weren't just visited. They were curated, like a cultural library, updated again and again over the course of millennia. This raises a quiet but profound question. Why keep painting the same places? Why return generation after generation to these cliffs and overhangs? The answer, according to many Aboriginal custodians, lies not in the visual content alone, but in the act of painting itself. These are not museums. They are living spaces. The stories depicted are part of a cosmological landscape, one where spiritual power can reside in stone and where painting renews ancestral connections. So while archaeologists might catalog motifs and styles, the communities connected to these artworks often describe them as alive, speaking, even protective. They are not windows into the past. They are presences. Still, from a scientific perspective, one of the challenges in studying ancient rock art is dating it. Unlike bones or charcoal, pigment does not always contain organic material. So researchers rely on indirect techniques, analyzing mineral crusts that form on top of paintings, or dating wasp nests built over the imagery. It is painstaking work, and it means our picture of the rock art timeline is still incomplete. But even with that caveat, the sheer scale of what survives is staggering. Tens of thousands of sites have been documented. Many more almost certainly remain undiscovered. Now comes the haunting part. For every image that has survived, how many have faded into the stone? And for every painting we can still see, how many meanings have been lost with the people who once explained them? In regions where traditional languages have gone quiet, or where colonial violence disrupted intergenerational knowledge, the interpretive bridge has broken. What remains is the outline of the story, but not always the language that gave it breath. So when we look at a gallery of long-necked birds, or wallabies, or mysterious humanoid shapes with massive headdresses, we are left with a tension. The art is there, but the full context might never return. Still, some patterns do emerge. One of the most enduring is the transformation in style over time. The early period, often associated with the Guion, shows fine detail, dynamic posture, and almost regal composure. Later periods transition into what is called the Yam style, with thicker lines and stylized motifs. Eventually, we see the emergence of X-ray art, a form unique to northern Australia where animals and humans are drawn with their internal organs visible. This wasn't just decorative. It reflected an understanding of the natural world as layered and interconnected. Some depictions even show unborn marsupials in wombs or the bones inside fish, hinting at an intimate knowledge of anatomy and a symbolic interpretation of life cycles. Interestingly, these shifts in artistic tradition don't seem to correspond with a break in cultural continuity. In many areas, there is evidence that rock art sites were maintained, repainted, or respected even as styles changed. This suggests that the artists saw themselves not as inventors, but as caretakers. In that sense, the paintings function less like signatures and more like verses in an ongoing songline, a kind of visual echo of the stories that run across the land. But here's the part that stirs the modern scientific imagination. While European Upper Paleolithic cave art, like that of Chauvet or Lascaux, often grabs the headlines, Australia's painted record may be longer and more continuous. It's not about competition, it's about perspective. In the Northern Hemisphere, Ice Age conditions forced populations to shift, abandon, or lose entire cultural zones. In Australia, despite the continent's own climate swings, there appears to have been more regional stability, at least in terms of population continuity. And with that comes continuity of memory, continuity of place. Now let's turn to the materials. The use of ochre in these artworks ties directly into a broader symbolic world. Ochre is not just pigment, it is ceremonial, medicinal, sometimes even ingested. The process of sourcing ochre, grinding it, mixing it with binders, and applying it to rock surfaces is itself a layered ritual. And certain ochre mines, like those found in Wilgimia in Western Australia, have been used for thousands of years. This makes ochre one of the oldest continuously used cultural materials on Earth. So what doesn't this vast rock art archive tell us? For one, it does not easily reveal names or voices. Unlike written scripts, these paintings don't identify authors, nor do they date themselves. And while they give us incredible insight into what was seen and imagined, they rarely tell us why. A flying fox with exaggerated limbs could be a spiritual totem, a clan symbol, a food source, or all of the above. Without the accompanying oral story, we are left interpreting the silhouette without the myth. That absence is both frustrating and humbling. It reminds us that archaeology can map pigment, measure strokes, and even date mineral crusts, but it cannot always restore meaning. That work requires dialogue, collaboration, and in Australia today, that collaboration is growing. Many rock art projects are now co-led by traditional owners, who provide cultural frameworks for understanding the images, advise on interpretation, and sometimes restrict access to sacred sites. This is not just about preservation, it's about permission, because these aren't ruins, they're relatives. And so the final question lingers. What will this archive look like in another 1,000 years? As the climate warms, as tourism increases, as industrial pressures touch even remote regions, many rock art sites face erosion, vandalism, or neglect. The pigments fade, the stone flakes, and without deliberate care, this visual memory could vanish. But the counterpoint is hopeful. Never before has there been so much attention on protecting and studying Australia's rock art. New scanning techniques, digital reconstructions, and indigenous-led cultural mapping are helping to preserve what the stone still remembers. The archive is ancient, yes, but it is also alive. And if you stare at those painted cliffs long enough, you might start to wonder, not just what stories they tell, but how many we've forgotten to ask. There are no written records from the time when humans first walked the coasts of ancient Sahul. No journals, no carved stone tablets, no oral stories that have survived word for word through 40,000 years. And yet, these people left behind one of the richest libraries in human history. It is not written in symbols or scripts. It is written in the stubborn, silent refuse of daily life. Piles of broken shells, layers of charcoal, and fire-cracked stones arranged in patient stacks beneath the soil. This is the archaeology of living, not ruling. It is not a history of kings or priests. It is the quiet accumulation of meals cooked, tools sharpened, bones tossed aside, and fires tended for warmth, light, and memory. And though we often privilege monumental things in history, skulls, tombs, statues, it is the stone hearth and the midden that most faithfully recorded the story of human persistence in prehistoric Australia. The earliest traces of this unwritten archive begin to appear in the archaeological record around 40,000 years ago, as human groups pushed further into the ecological edges of the continent. Along the northern and eastern coastlines, researchers have uncovered dense layers of shell middens, essentially ancient rubbish heaps made up of discarded mollusk shells, fish bones, charcoal, and burnt rocks. They might not sound glamorous, but they are one of the clearest records we have of long-term, stable occupation. A single midden can span thousands of years, its layers preserving a near-continuous record of what people ate, how they cooked it, and which habitats they preferred. At places like Keppel Bay in Queensland or Cheetah near Cape Le Grand in Western Australia, these middens lie just above the high tide mark, stubborn markers of once thriving camps, gradually layered by generations of hands tossing oyster shells and sea snail husks into the same growing mound. Through isotopic analysis and microscopic wear on shell fragments, scientists can now reconstruct not only what was eaten, but in what season, how it was processed, and how local marine ecologies changed over time. In many cases, these sites suggest an incredibly adaptive and resilient coastal lifestyle, maintained with only modest technological shifts across tens of thousands of years. Beyond the shells themselves, the charcoal layers interwoven through these middens tell another part of the story. Hearths were not only used for cooking, they were social centers, gathering points, signal fires, protection against predators, and sometimes, accidentally or not, tools for reshaping the land. The consistent appearance of fire-altered stones, arranged in roughly circular or oval patterns, points to repeated deliberate construction of hearth features. Thermoluminescence dating of these stones has helped establish timelines for site occupation that go well beyond what radiocarbon alone can reveal, particularly when organic material is sparse. At sites such as Devil's Lair in the southwest, or at the Baril Lake shelter further east, these fireplaces recur again and again in the same footprint, sometimes rebuilt on top of one another over millennia, like geological palimpsests of human return. They suggest not a random wandering across the land, but a rhythmic pattern of seasonal use, people coming back to the same places because they knew them, trusted them, and perhaps because they had always belonged to someone. What is especially striking is the geographical spread of these midden and hearth sites. By 30,000 years ago, such remains appear not only along lush coasts, but even in arid inland zones, indicating that early Australians were not simply passive recipients of environmental bounty, they were active managers of space, knowledge, and fire. Along the now dry Lake Eyre Basin, burnt stumps and charcoal layers embedded in ancient dunes suggest that even the interior deserts were exploited during wetter periods, likely through sophisticated seasonal mobility. In the Pilbara region, researchers have found evidence that large quartz stones were sometimes carried over considerable distances, possibly as preferred hearth components or as part of trade or social exchange networks. These scattered remnants of fire and food speak to a knowledge system that was not recorded on paper but transmitted through land, stone, and memory. The story of adaptive resilience becomes clearer when we compare these archaeological signatures across regions. In the tropical north, shell middens lean heavily on mangrove and estuarine species like mudwhelks and mangrove crabs, while in the southern regions, they tend to favor open-coast mollusks like limpets and periwinkles. Inland, burned kangaroo bones and emu eggshell fragments begin to appear in campsites, sometimes mixed with riverine mussels carried from nearby waterways. These shifting menus reflect not only environmental diversity, but human innovation in harvesting, processing, and preserving food across vastly different ecological niches. In some regions, the presence of grinding stones alongside hearths suggests early use of plant processing, possibly for tubers or seeds, technologies that would later develop into some of the world's oldest baking traditions. Yet as much as these stone records illuminate, they also conceal. One of the most frustrating aspects of Midden archaeology is the sheer unevenness of preservation. Coastal sites, especially those closer to the modern sea level, are vulnerable to erosion, sea level rise, and even modern development. Entire chapters of prehistory likely lie underwater now, drowned as post-glacial seas rose dramatically between 20,000 and 7,000 years ago. Some middens may have been scoured away by storms, others buried deep beneath sediments or lost beneath cities and farms. What survives is as much a matter of luck as of preservation conditions. And so, the silence in the record, the places where nothing has been found, should not be mistaken for absence of activity. Another limitation lies in interpretation. While the shells and stones tell us what was consumed and burned, they reveal little about the meaning of these acts. Were certain foods taboo for some individuals? Were hearths gendered spaces? Did middens carry spiritual or territorial significance beyond their practical function? These questions lie mostly beyond the reach of material evidence. And yet, the endurance of these sites over tens of thousands of years suggests that knowledge was not just functional, but cultural, embedded in stories, traditions, and rules passed from elder to child, encoded in the land itself. Even if the archaeological record cannot recover these meanings in full, it points to a social fabric rich with repetition, ritual, and placemaking. The haunting question that remains is whether these humble stone records can ever fully account for the intellectual world of their makers. In the absence of bones, artifacts, or explicit art, the fire pit and the shell heap may seem like the background noise of prehistory, but perhaps that is where the real story lives, not in the rare and dramatic finds, but in the evidence that people stayed, cooked, shared, and returned. In the repeated building of hearths and the steady addition to a midden, we see a world not of chaos or survival alone, but of continuity, planning, and belonging. The fire was not just a necessity, it was an anchor. What might our own descendants make of our rubbish heaps 10,000 years from now? Will they read the layers of plastic, glass, and carbon as proof of our resilience, or as evidence of something else? We can't know. But looking back at the stone and shell archives of ancient Australia, we are reminded that history is not always told through monuments. Sometimes it is written in soot, in crumbs, in heat. And sometimes the most enduring story is the one left behind by people who never intended to be remembered. For most of human history, there were others. They are gone now, but not entirely. When we speak about the first people who reached Australia, there is a quiet presence in the genetic story that almost no one could see coming, not because we lacked imagination, but because for most of the 20th century, we simply did not know they existed. The Denisovans. A name given not to a civilization, but to a molar, a finger bone, a single toe. What we know about them could fit into the palm of your hand, yet their legacy lives on in the bodies of millions of modern people, especially those descended from the ancient populations of Southeast Asia, New Guinea, and Aboriginal Australia. The strange part is not that they interbred with Homo sapiens. The strange part is that this invisible inheritance, this memory etched into chromosomes, might be stronger in the regions of the world where no Denisovan fossil has ever been found. The Denisovans were first identified in the early years of the 21st century, not through full skeletons, but through genetic sequencing. In a cave in the Altai Mountains of Siberia, researchers extracted DNA from the crushed remains of a child's finger, unearthed in a sediment layer over 50,000 years old. The results were unlike anything seen before. This was not a Neanderthal. This was not a modern human. It was something else, something closely related to both, but genetically distinct. We named them after the cave they were found in, Denisova. From that moment, a whole field of prehistoric research tilted. Suddenly, we had to accept that at least 3 kinds of human had been sharing the planet at once: Homo sapiens, Neanderthals, and these silent, mysterious Denisovans. But the mystery deepened, because even though we had never found a Denisovan fossil in Southeast Asia or Australia, we were finding their genes there, in abundance. By sequencing the DNA of modern populations across Asia and Oceania, researchers began to detect traces of Denisovan ancestry. The findings surprised everyone. In mainland Asia, the percentage of Denisovan DNA was low, less than 1% in most populations. But as the genetic survey moved southeast, the numbers began to rise. In Melanesia, Denisovan ancestry reached between 4 and 6%. Among Aboriginal Australians, similar levels were recorded. These were not statistical noise, these were biological echoes. And yet no Denisovan bones had ever been found in these regions. The trail was genetic, but the bodies were gone. It posed a fundamental question: where did the mixing happen? The current models suggest multiple episodes of interbreeding between Homo sapiens and Denisovans, possibly in different regions and times. One hypothesis places the encounter in Southeast Asia, perhaps somewhere in the complex archipelagos of Wallacea. This is the same zone where early humans had to navigate island chains, vast sea crossings, and unfamiliar ecosystems in their journey toward Sahul. In this scenario, as Homo sapiens moved through maritime Asia between 70,000 and 50,000 years ago, they encountered populations of Denisovans already adapted to tropical climates, already shaped by hundreds of thousands of years of evolution in isolated island environments. The admixture occurred. Then the Homo sapiens moved on, carrying the genetic fragments with them into the deep south, toward what would one day become Australia and New Guinea. But there is another model, one with even fewer certainties. This model suggests that Denisovans were not a single population, but a scattered, diverse group with multiple lineages spread across Asia. Some lived in the highlands of Tibet, where we have now found a jawbone dated to over 160,000 years ago. Others may have lived in island Southeast Asia, or even further east. In this view, the term Denisovan is a genetic umbrella, not a species label. It may be that what we call Denisovan DNA in Australia does not all come from the same source. It may be that our categories are too simple for the complexity of deep time. What matters is the outcome, that sometime, somewhere, humans and Denisovans met, and children were born. One of the more fascinating implications of this genetic legacy is that it may not be neutral. Some of the Denisovan genes carried by modern populations are involved in immune function, metabolism, and adaptation to climate and altitude. In Tibetans, a gene inherited from Denisovans helps them survive at high altitudes by regulating oxygen use. In populations of Melanesia and Australia, the precise effects are still being studied. But it raises a broader question: were these genetic borrowings accidental or advantageous? Did interbreeding with Denisovans help Homo sapiens survive in unfamiliar ecosystems? Was this a form of genetic preparation for the world to come? It is important to acknowledge that we do not yet have all the evidence. We do not know how many Denisovan populations there were. We do not know where they lived or how they looked. We have only a few teeth, a jaw, and one partial skull, and even these do not tell the full story. No Denisovan fossil has ever been found in Australia. No archaeological site has been definitively linked to them. Their presence is written in blood, not in bones. And that is what makes this story so compelling. It is a detective case with almost no clues, except the ones inside ourselves. Some researchers suggest that the reason we cannot find Denisovan fossils in Southeast Asia or Sahul is simply that the region's climate and soils are hostile to bone preservation. The tropics are hard on skeletons. Acidity, humidity, and biological activity degrade remains quickly. Others suggest we have not been looking in the right places. Until recently, Denisovans were invisible to science. Now that we know what to look for, both genetically and geochemically, it is possible that more traces will be found. Perhaps not full skeletons, but fragments, teeth, isotopes, proteins, tools, or perhaps nothing. That too is part of the story. In the absence of physical remains, What we do have is a growing body of ancient DNA research, which continues to refine our models of early human movement and mixture. Each new genome sequenced from ancient individuals in the region adds another pixel to the picture. But the image is still blurry. It may always be blurry. This is not a failure of science. It is a reminder that history, real history, is full of gaps. Not everything survives. Not everything is knowable. That is why we must approach these questions with both rigor and humility, because the past does not owe us clarity. It only offers hints. And so we are left with the haunting truth that some of the first Australians carried within them the genetic memory of another kind of human, one who had walked the earth long before their arrival. We do not know what they looked like. We do not know what language they spoke, or if they spoke at all. We do not know what they called the stars. But something of them remains. And when the first footprints were pressed into the ancient shores of Sahul, when fires were lit and ochre was crushed, when children laughed and stories began to pass between generations, a few of those stories, perhaps, came from further back than anyone could imagine. We tend to think of prehistory as belonging to a single species, but the deeper we look, the less true that becomes. The past was crowded, it was messy, it was shared, and for a brief time, the human story was not one lineage, but many, braided together in ways we are only beginning to grasp. So when we look at a face in the mirror, or trace the silhouette of a continent, or whisper the names of vanished peoples, we might remember that there were others here, not ghosts, not myths, but relatives, in the oldest sense of the word. What we carry from them is not only genetic, it is a lesson in humility, that even when history leaves no record, influence can persist, that the land remembers what the textbooks forget, and that some of the most important chapters in our story were never written, they were inherited. The skull had actually been discovered long before, back in the 1930s, pulled from a riverbank in northern China. It was called the Harbin skull, named after the city where it had been found. For decades, it sat unstudied, locked away for political reasons, and passed between families who may not have realized what they were holding. It was only in the early 21st century that scientists began to examine it in depth, and even then, there was uncertainty. It looked too strange, too large, too different. Some called it Homo longi, the dragon man, and argued that it might be our closest evolutionary cousin. But without DNA, the debate swirled, until that year, 2025, when researchers finally managed to extract genetic material not from bone or marrow, but from ancient calcified dental plaque. That tiny scrap of preserved biological residue allowed them to do something no one had yet done: match a full skull to Denisovan DNA. For the first time, the face of the Denisovans was no longer an artist's guess. It had a brow, a jaw, a brain case. It had weight, presence, dimensions, and it turned out to be big. The Dragon Man skull is one of the largest hominin crania ever found, with a brain size rivaling or even exceeding that of modern humans. Its massive brow ridges, large eye sockets, and flattened cheekbones suggest a powerful, cold-adapted body, perhaps shaped by life on the open plains of Ice Age northern Asia. But its most important feature, perhaps, is simply that it exists, because it gives us something the Denisovans had long denied us: a body, a skeleton to match the genes. And with that, we can begin to build bridges between places that seemed impossibly far apart, like Siberia, China, Papua, and the ancient continent of Sahul. When archaeologists first began digging into Australia's deep past, they relied mostly on tools, fire pits, and bones. The fragments told a story, but not the whole story. It was like listening through a wall. You could hear voices, but not always the words. Then came a new kind of evidence. Not from charcoal, not from stone, but from inside us. DNA. Inside the cells of Aboriginal Australians today lives one of the oldest continuous genomic lineages on Earth. And by listening to what that DNA says, and just as importantly, what it doesn't say, scientists have been able to trace a trail back through tens of thousands of years, not just through land and sea, but through time. And what they're finding is remarkable. Not only is this trail long, it is stubborn. It refuses to break. Unlike the tangled and frequently interrupted histories of other regions, the Aboriginal genetic story has been a slow, continuous river, flowing straight from the past into the present. Let's start with what that means. Genomic continuity is a phrase that gets used a lot, but in this case, it is not just poetic, it is statistically shocking. Most populations on Earth today cannot trace an unbroken lineage back to the Pleistocene. Climate shifts, invasions, famines, conquests, and migrations have reshaped gene pools over and over again. But Aboriginal Australians are different. Their ancestors arrived in Sahul around 60,000 years ago, and the DNA suggests they stayed. They did not get replaced, displaced, or overtaken. The people alive today are, genetically, direct descendants of those first arrivals. This is not just a political statement. It is not symbolic. It is measurable in the base pairs of their genome. That kind of continuity is rare, possibly unique. And it tells us something important. Australia has always been a different kind of story. The genetic timeline begins with the out-of-Africa migrations that occurred between 70 and 60,000 years ago. As Homo sapiens moved along the southern coast of Asia, small groups split off and kept moving east. Some of them eventually made it to the island chains of Wallacea, and from there to Sahul, the ancient megacontinent that joined Australia, Tasmania, and New Guinea during the Ice Age. Once there, they didn't just survive, they settled. And remarkably, within a few thousand years, they began to diverge. One of the more surprising insights from genomic studies is just how early Aboriginal groups within Australia began to split from one another. Based on current models, many of these population splits may have occurred as early as 50,000 to 40,000 years ago. That means that some language and kinship groups in the north and west of the continent have been distinct for longer than the entire history of agriculture, longer than cities have existed, longer than Homo sapiens have lived in Europe. In other words, diversity within Australia is not a recent phenomenon, it is ancient, incredibly ancient. What makes this even more compelling is the fact that this divergence did not come from new migrations. The genetic evidence does not support repeated waves of incoming peoples over the millennia, as seen in Europe or Asia. Instead, it appears that once humans reached Sahul, the populations began to radiate outward, adapting to local ecologies, forming new languages, new cultural systems, and eventually new genetic identities, but always within the same broader ancestral framework. That is, no matter how different Aboriginal communities may appear today, their DNA still links them to a single ancient migration, a single deep-time origin. There is variety, but no rupture. Genetic clocks are how scientists estimate when populations diverged. These clocks are based on the rate at which DNA mutations accumulate over time. The process is imperfect and often debated, but it provides one of the best tools we have for reconstructing long-term human history. In the case of Aboriginal Australians, these clocks suggest that their genome split from that of mainland Asians roughly 50 to 60,000 years ago. And within Sahul, population splits likely began not long after. That early split between Aboriginal Australians and Papuans, for example, may have occurred around 37,000 years ago, when rising sea levels began to sever the land bridge between what is now northern Australia and New Guinea. The ocean, once a highway, became a wall. But the DNA remembers the time before the wall existed. In the highlands of Papua New Guinea, the story takes another turn. Isolated by rugged mountains and rainforest, some groups develop genetic profiles so distinct that they appear as some of the most divergent Homo sapiens lineages ever recorded. This divergence is not the result of admixture with archaic humans or other species. It's simply the result of long, continuous separation and small population sizes, genetic drift stretched out over tens of thousands of years. It's another reminder that isolation, not just movement, can shape who we become. Meanwhile, in Australia, the trail of continuity continued. Ancient DNA studies from archaeological sites are still rare, mostly due to poor preservation in hot climates. But where they do exist, they confirm the pattern. Individuals buried tens of thousands of years ago share close genetic relationships with modern communities in the same region. This was demonstrated most clearly at Lake Mungo, where DNA recovered from ancient remains pointed toward a lineage distinct from modern humans elsewhere, but was later shown to be an artifact of contamination. Still, the lesson stuck. DNA is powerful, but it must be handled carefully. And while the Lake Mungo individual remains one of the most famous burials on the continent, the broader genomic story comes not from a single skeleton, but from living descendants. Modern genome-wide studies conducted in collaboration with Aboriginal communities have deepened this picture. They show not just continuity, but structure. Complex internal population patterns, some of which track with language families, river systems, or ecological zones. Others defy easy explanation, and all of it together suggests a deep-rooted connection between people and place, one that stretches back far beyond the reach of memory, tradition, or even archaeology. This is not just ancient DNA, it is living ancestry. But even this trail has questions. One of the most pressing is the possibility of earlier, now extinct human populations in Australia. Some researchers have wondered whether Homo erectus or other archaic humans ever made it this far. So far, the evidence says no. There are no confirmed pre-sapiens fossils in Australia. But the presence of Denisovan DNA in Aboriginal genomes raises the tantalizing possibility that other hominins once passed through the region, or at least nearby. If so, where are they? Were they absorbed, outcompeted, lost to sea level rise or erosion? We don't know. The DNA whispers, but the ground is still quiet. Another question is how stable this continuity really was. While the genome shows little evidence for large-scale replacement, it is possible that small, localized population turnovers occurred, perhaps following climatic shifts or natural disasters. The last glacial maximum, around 20,000 years ago, would have tested even the most resilient communities. But so far, the genetic signal suggests survival rather than collapse, adaptation rather than abandonment. What makes this story even more astonishing is that all of this happened in relative isolation. For tens of thousands of years, the people of Sahul lived without significant contact with the rest of the world. While other regions experienced waves of migration, trade, and conquest, Australia and New Guinea remained largely self-contained. That is, until the last few thousand years, when contact with Austronesian-speaking groups in the north brought new languages, new technologies, and perhaps minor genetic contributions. But even then, the genomic core remained. The ancient trail stayed intact. This brings us to a question that is both scientific and philosophical. How far back can DNA really take us? In the case of Aboriginal Australians, the answer is unusually far. But even this trail has a horizon. Beyond a certain point, the mutations blur. The trees branch too much. The certainty fades. And we are left with inferences, probabilities, best guesses. But even so, the fact that we can look at a living person today and see a lineage that stretches back over 60,000 years without being severed, colonized, or replaced is profound. It tells us something about the power of continuity and the deep-time resilience of culture and biology. And yet, even this resilience is vulnerable. Genetic diversity in some Aboriginal groups has declined in recent centuries due to displacement, disease, and demographic collapse following European colonization. The damage done in the last few hundred years is real and measurable, but the fact that the deeper genomic layers are still intact is a testament not just to survival, but to memory. Memory not in books or carvings, but in molecules. A story carried in the body, passed from mother to child, unbroken. So here we are, at the end of a trail that began 60,000 years ago and that continues today. A story written in chromosomes, in silent code, in the double helix. It is not a myth, it is not a symbol, it is a data set. A living data set that says, these people were here, they are still here, and they carry with them a history so long that it cannot be held in a single timeline, a single language, or a single story. And that leaves us with one final question. If this much can be learned from DNA alone, what are we still missing? What other stories lie inside us, waiting for the right technology, the right question, the right partnership to bring them out? And what happens to the past when it turns out it never really left us? For much of the 20th century, there was one story that tried to explain where humans came from. It was tidy, linear, and easy to visualize. The idea was that modern Homo sapiens emerged somewhere in Eastern Africa about 200,000 years ago, and then spread across the world, replacing all earlier hominins as they went. This was called the out-of-Africa model, and for a long time it held strong. Fossil evidence from Ethiopia, genetic studies from mitochondrial DNA, and the sheer diversity of African populations seemed to support it. According to this view, Australia, like the rest of the world, was colonized by one single wave of modern humans. But as more fossils were found, and as DNA technology advanced, the story began to get less tidy. Another model, long dismissed but stubbornly persistent, returned to the table. This one was called multi-regional evolution, and it said something quite different. According to this theory, modern humans didn't just appear in Africa and take over. Instead, Homo erectus populations that had already spread across Africa, Asia, and possibly even Europe slowly evolved into modern humans in parallel, with ongoing gene flow between the regions. In this view, humans evolved everywhere, together, not as a single species replacing others, but as a network of populations gradually shifting towards something new. It sounds romantic, cooperative, global, but for decades, it was seen as too generous to fit the fossil record or the genetic data. The replacement model was simpler, cleaner, more measurable. But then the DNA started speaking. In 2010, the first draft of the Neanderthal genome revealed that non-African humans carried Neanderthal DNA. Then came Denisovan DNA, pulled from a finger bone in a Siberian cave, which turned out to be a ghost lineage we never knew existed. And just like that, the clean picture cracked. Modern humans had not replaced other hominins cleanly. They had met them, interbred with them, absorbed them. The new model began to emerge not as a clean alternative, but as a kind of scientific braid. Some called it the assimilation model. Others began speaking of a braided stream or a network. Whatever the metaphor, the message was clear. Human origins were messy. What does this have to do with Australia? Quite a lot, actually. Because Australia is one of the final frontiers in the global story of Homo sapiens. It represents one of the earliest known long-distance sea crossings in human history, and it has one of the longest continuous human occupations anywhere on Earth. But there's a mystery. Some researchers have noticed that the morphology of ancient Australian skeletons, especially from places like Cow Swamp, seems different. The skulls are unusually robust, the facial bones thick, the brow ridges more pronounced than in other early Homo sapiens populations. For some, these traits hint at a deeper, possibly regional lineage, a relic of archaic ancestry, something more than just out of Africa. Now, it's important to be careful here. These differences could easily be explained by environmental adaptation, diet, or even just normal variation within the Homo sapiens range. But others have speculated about something more. Could it be that Australia preserves traces of a more complex story? One in which early Homo erectus populations in Southeast Asia, like those who made the tools at Ngandong or Sangiran, left some genetic legacy in the wider region? We now know, thanks to Denisovan DNA, that interbreeding did happen in or near Wallacea. That fact alone makes the genetic story of Sahul far more interesting than a simple wave of replacement. The discovery of the Harbin skull in China, Dragon Man, has only deepened the mystery. Dated to between 200,000 and 146,000 years ago, the skull has features that align with what we now call Denisovans. And in 2025, DNA analysis from dental plaque finally confirmed it. The Dragon Man was a Denisovan, which means we now have a face, or at least a cranium, for this ghost species. And this Denisovan DNA is present in low but significant percentages in modern Aboriginal Australian genomes, not just a few individuals but consistently across broad regions. That suggests that the meeting between Homo sapiens and Denisovans wasn't just a one-time event in a distant cave. It likely happened in multiple locations, possibly over centuries. And one of those locations might have been close to the stepping stones that led to Sahul. If so, what does that mean for the evolution debate? Does this push us closer to a multi-regional model, or does it just complicate the out-of-Africa story? The answer is both. What most researchers now accept is that modern humans did indeed originate in Africa. That much still holds. But the journey out was not a replacement, it was a remix. Populations moving into Asia and beyond encountered older hominins, interbred with them, and incorporated some of their genes. In some regions, the genetic contribution was minor. In others, it left more visible traces, not just in DNA, but perhaps in morphology, culture, and behavior. And over tens of thousands of years, these braided streams became us. What we see in Australia is one of the clearest test cases for this idea. A population that arrived early, stayed long, and lived largely without interference from later waves of human movement. That isolation, combined with genetic continuity, makes Australia a kind of time capsule, a way to test the theories without all the later noise. And what it seems to be telling us is that neither model, out of Africa or multi-regional, is fully wrong. But neither is fully right either. The truth lies in the interactions, the in-between zones, the Wallaceias, the Denisovans, the now drowned coastlines where meetings may have happened that left no archaeological trace, only DNA. Of course, there are still massive gaps. The fossil record in Southeast Asia is patchy. Ancient DNA is hard to extract from tropical soils, and many key sites have likely been swallowed by the sea. But the trend is clear. Every year, the story gets messier, and in that messiness, we find something strangely hopeful. Human evolution wasn't the march of one perfect species taking over the world. It was a long, slow mosaic. A survival quilt stitched from many lineages, many adaptations, many small encounters that added up to something big. So the next time someone asks where humans came from, you can answer truthfully, it's complicated. Africa gave us the blueprint. Asia gave us the remix. Australia kept the record. And somewhere between all of them, we became who we are. Which leaves only one haunting question. What other pieces of the mosaic have we lost? Maybe they lie under the jungle, maybe beneath the sea, maybe in DNA we haven't sequenced yet, or maybe, like the Denisovans, they're waiting to be recognized. Not as strangers, but as chapters in our own story, written in fossil, in myth, and in the slow evolution of a species that never stopped becoming. If you woke up tomorrow to find all the books gone, the data wiped, the satellites silent, and the museums empty, what would be left to remember the shape of the world? In much of the modern West, the answer would be not much. Memory outsourced to machines does not tend to last long when the batteries die. But in Aboriginal Australia, memory has not been externalized, it has been ritualized. And some of it appears to have lasted not centuries, but millennia. Some of it may have lasted through sea level rise, extinction events, glacial retreat, and the drowning of entire continents. Stories here are not just told, they are walked, sung, inherited, mapped onto the land. And if we take them seriously, not as metaphor, but as lived oral geographies, they may tell us something science is only now catching up to. That knowledge, if ritualized into memory and tethered to place, can survive deep time. For most of the last 2 centuries, mainstream archaeology treated oral traditions like fog, poetic, vague, and ultimately unsuitable as evidence. Stories were seen as mythic baggage, imprecise and shaped too easily by imagination or ideology. But that assumption has been quietly unraveling. One of the key reasons is climate science. By modeling past coastlines during the last glacial maximum, when sea levels were more than 100 meters lower than today, researchers have been able to reconstruct now drowned land masses and shorelines. These reconstructions, when overlaid with traditional Aboriginal accounts of landscape transformation, began to match in unsettling detail. Stories told by coastal groups, from the Kimberley to southern Victoria, remember sudden floods, vanishing islands, and the rise of seas where once there was land. Some communities speak of a time when the coastline was far out to sea. Some describe walking to places that today lie underwater. These are not abstract myths. They are topographic memories, and their specificity is hard to dismiss. Take the Gulf of Carpentaria. Around 20,000 years ago, it was not a gulf, but a vast inland basin dotted with freshwater lakes and river systems. Several Aboriginal groups in the region hold stories of this terrain being flooded, of the sea rising and transforming the landscape. Or consider Port Phillip Bay near Melbourne. Today, it is a broad saltwater inlet, but around 8,000 years ago, it was dry land, and some of the local Wathaurong stories seem to preserve an account of that dramatic shift. In total, more than 20 locations across the Australian coast now appear to have oral histories that plausibly match geological evidence of post-glacial sea level rise between roughly 10,000 and 7,000 years ago. If these correspondences are real, and not coincidence, they suggest a cultural continuity that predates most civilizations on Earth. How can stories survive 10,000 years? That's the uncomfortable question this evidence raises, and the honest answer is, we do not fully know. But one possibility lies in the nature of mnemonic systems embedded in Aboriginal cosmology. The dreaming, or chukurpa, is not just a mythological time. It is an organizing framework for memory, law, morality, and environment. Dreaming stories link places and ancestors, behaviors and species, tools and taboos. They are not merely tales to entertain. They are education systems, ecological guides, navigational tools, and sacred codes all in one. Through repetition, ceremony, and spatial anchoring, they preserve relationships between people and places with stunning precision. Songlines, in particular, serve as geographic memory maps. They track the roots of ancestral beings across the land, encoded in melody and choreography, often covering hundreds of kilometers. And these songlines are still sung, still walked, still taught. Some include reference points that are now beneath the sea. The notion that oral cultures are necessarily ephemeral now seems naive. Oral traditions can be remarkably stable, not despite their flexibility, but because of it. They allow for retelling, for adaptation, while maintaining the core structure. When a landscape changes, when a hill erodes or a coastline shifts, the story does not collapse. It stretches. It remembers what came before. And this resilience gives it an advantage over many written records, which are tied to the assumptions and environments of a single moment in time. Of course, there are risks of overinterpretation. Just because a story mentions water rising or land vanishing does not prove it refers to a specific paleogeographic event. Memory is not a photograph. It is layered, symbolic, refracted through generations. Correlation is not causation. But the pattern here, dozens of independent stories across thousands of kilometers, aligning with known episodes of sea level rise, is difficult to ignore. At the very least, it challenges us to treat indigenous knowledge systems not as folklore, but as parallel epistemologies, not as superstition, but as science by other means. And this is where things get more profound. Because when we ask what stories can teach us about landscape change, we are also asking what kinds of knowledge we choose to value. Modern science depends on instruments, replication, peer review. It is powerful, but it is also young. The written word, in the Australian context, arrived barely 200 years ago. Indigenous oral traditions had already been running for tens of thousands. That is not just impressive. It is a different kind of data record, one that requires a different kind of listening. We are beginning to see attempts at that listening. Collaborative projects between Aboriginal elders and climate scientists, between linguists and geologists, are attempting to triangulate ancient stories with environmental timelines. In some cases, what emerges is a blended map, part poetic, part empirical, where the past is remembered not through books or satellite imagery, but through smoke, sand, and voice. And the stories don't just recall loss, they encode survival strategies. They remember how ecosystems changed, where resources shifted, how people adapted when the seas came. In this way, oral history is not only retrospective, it is instructive. The haunting question is what else these stories might contain that science has not yet verified. If memory can preserve coastlines for 7,000 years, could it also preserve species, climatic cycles, or extinct behaviors? Could it remember volcanic eruptions, meteor impacts, ancient droughts? There are stories from the Yolngu people in Arnhem Land that describe what may be the formation of craters. Others from Western Victoria speak of fire from the sky, possibly referencing ancient meteorites. We do not yet know what to do with these accounts. But they are not noise. They are signals. And it may be our model of knowledge that needs recalibrating to hear them. Ultimately, this is not just a story about Australia. It is a story about how humans remember. It suggests that memory, when anchored to landscape and embedded in ritual, can become more than recollection. It can become infrastructure. And if so, the oldest maps on Earth are not carved into stone or stored in clouds. They are sung. So we come back to the quiet shock at the heart of this episode. The possibility that an ancient song or a firelight tale, passed across 400 generations, might carry information about a world we forgot was even real. That a story told in a bark shelter, under a sky of ancestral stars, might describe a beach that hasn't existed since the glaciers melted. That memory, in the right conditions, may last longer than cities, longer than empires, longer than even the languages we speak. And that forces us to ask, what knowledge are we preserving today with enough care that it will survive 10,000 years? Are our systems of memory resilient? Are our stories worth remembering? Or are we becoming forgetful apes, outsourcing wisdom to servers that crash and passwords we forget? In Aboriginal Australia, at least, the answer has already been given, and it is still being sung. Not just because the past matters, but because the future might still be listening. In the dry lake bed of Mungo, in what is now southwestern New South Wales, there is a place where the sand remembers fire. Not the wildfires that flash through eucalyptus scrub, but something quieter, more intentional. A small fire built for a specific purpose nearly 42,000 years ago. Not for warmth, not for cooking, not for survival, but for farewell. Here, under ancient dunes shaped by ice age winds, someone was burned. Not in haste, not by accident, but ritually. A human body, deliberately cremated, then buried. It is the earliest known cremation in the archaeological record. And for all the times we have burned things since, forests, heretics, cities, this moment still burns with significance, because it tells us something subtle and immense, that by 42,000 years ago, people were already treating death as something worth remembering. The woman whose bones were found in this spot was uncovered in the late 20th century during research into the sediment layers of Lake Mungo. What was found were the fragmentary remains of a body that had been burned twice, once with the flesh still on, and then again, crushed and burned again, after the initial cremation. Her bones had been broken, perhaps ritually, perhaps as part of the cremation process, and buried in a shallow, oval-shaped pit. This is not how bodies decay when left to the elements. This was deliberate, which raises the first quiet revelation. Humans in this time and place had symbolic behavior complex enough to include fire, not just as a tool, but as a transition. We do not know who she was. Her identity is irretrievable, but what she left behind was not. Her remains are often called Mungo Woman, though even that is a name we give in the absence of hers. All we really have is a burned body, a pit of white ash, and a moment frozen in sediment. But what a moment. Until her discovery, the earliest known cremations came from the Neolithic period in Europe, some 6,000 or 7,000 years ago. This event pushes the timeline back dramatically. It tells us that by 42,000 years ago, long before agriculture, before pottery, before metallurgy, people were engaging with the dead in a way that transcended the biological. The body was not just disposed of, it was transformed. Why fire? That question echoes across millennia. Fire has always had an ambiguous power. It can cook, cleanse, destroy, sanctify. To cremate someone is to use flame not just as an element, but as a metaphor. It strips away the body, leaves only trace and residue, and perhaps, in some cultures, frees the spirit. But was that how it was understood here, at this lake, in this time? We do not know. No oral tradition from this exact region has survived that far back. There is no song line we can point to with certainty. What we are left with is inference, a body burned, buried, and the haunting knowledge that someone, or some community, chose to do this, chose to return her to the earth as flame and bone. The bones themselves reveal further intricacy. The way the cremation was done suggests knowledge of fire control. A body does not fully combust unless temperatures are sustained and airflow is managed. This was not a bonfire with a body thrown in. It was more controlled, more intentional. The process indicates technological competence, but also emotional meaning. You do not cremate a loved one by accident. This was not practical disposal. It was ritual behavior, carried out in a landscape they knew, with a technology they understood, for a reason we can only guess. And that is the hardest part of all this, the guessing. Because what does it really mean to find the world's earliest cremation? Does it mean grief was already complex? Does it suggest a belief in an afterlife? Or is that us projecting later behaviors backward onto the deep past? The truth is, we do not know. Archaeology can tell us what happened. It cannot always tell us why. What we do know is that in this place, at this time, a human death was marked by fire, and that fire was buried. That is not nothing. That is a signal, a sign that something mattered. Some researchers suggest this may mark the origin of funerary culture in Australia, or at least the oldest trace of it. But that phrasing is always risky. Culture does not start, it accumulates. What we see here is likely the fossil of a tradition already in motion, and it forces us to revise the timeline of when humans began to ritualize death. This was not an invention of farming societies or Bronze Age cities. It was already happening among mobile foragers in Ice Age Australia, and not in a hidden cave or a secret shrine, but in open country, by the lake, under sky. The sediment layers around the cremation site have been studied extensively. Radiocarbon and optical dating methods have placed the event to roughly 42,000 years ago, give or take several hundred years. The precision may never be exact, but it anchors the event deep in the Pleistocene. At this time, the megafauna still roamed inland Australia. The sea levels were low. Sahul was still intact, a massive continent that joined New Guinea and Tasmania to the mainland. And here, in this vast landscape, someone burned a woman and buried her in a deliberate act of closure, of ceremony, perhaps of mourning. From a biological standpoint, her remains also carry information. Analysis suggests she was lightly built, possibly elderly, and most likely of local origin. Stable isotope studies and anatomical reconstructions have tried to glean more about her life, her diet, her mobility. But the data remains limited. She is most powerful not because of what her bones tell us about physiology, but because of what her cremation tells us about cognition, about meaning, about fire and memory. There are still debates. Some argue whether this really was cremation in the modern sense, or a more fragmented fire burial. Some suggest the remains were burned in situ, others that the bones were moved and reburned later. But even with these disagreements, the central fact remains unchanged. Someone was burned and buried with intentionality in Australia tens of thousands of years ago. And that act reshapes how we think about what it means to be human. Because this was not survival behavior, it was symbolic behavior. And that matters. It means that by 42,000 years ago, humans on this continent were already operating with a complex framework of meaning. They already marked transitions, already differentiated between life and death in a way that called for performance, gesture, fire. And this is not something all species do. Even among early humans, ritual cremation is rare. It suggests abstraction, maybe even belief. We cannot know what they believed, and it is important not to rush that mystery. The silence around this woman's burning is part of her story. It is the silence of a world before writing, before borders, before nation-states or chronicles. A world in which stories were told through ash and firelight, through the arrangement of bones, through choices made in grief. Perhaps that is what makes this one of the most haunting sites in all of human prehistory. Not because it proves something definitive, but because it invites us into a moment of emotion we can barely reconstruct. A group of people, gathered on the edge of a lake that no longer exists, said goodbye to someone. And they did it with fire. That fire burned for only a few hours, but its traces burned much longer, through sediment, through erosion, through time, until we found them. And what we choose to do with that moment, how we frame it, how we listen to it, how we acknowledge our own ignorance about it, may matter more than what we can explain, because sometimes, to understand the past, you do not need to know all the facts. You need to accept the depth of the questions. You need to recognize what it means when humans begin to treat death not just as an end, but as a passage. So we stand here 42,000 years later, not to explain her, but to witness her. The fire is long gone. The sand has shifted, but the act remains. She burned. And in that burning, something about us, all of us, was already taking shape. There is a body in the dunes of Lake Mungo, buried in a shallow pit and covered in red, not red from the natural rust of soil, but from something chosen. Crushed, powdered, placed deliberately. Ochre, a vivid iron-rich pigment that does not occur naturally in the region. It was brought here, carried from a distance, ground by hand, and poured onto a man who had died. It is not the burial itself that turns the ground sacred. It is the color, the decision, the meaning carried in the act. At a time when glaciers still ruled the poles and sea levels were far below modern coastlines, a group of people in the arid interior of Australia chose to mark a human death not with fire, but with earth. This burial, known in the archaeological record as Lake Mungo III, was discovered in the late 20th century, exposed by shifting sands on the western edge of the dried lake bed. The skeleton was remarkably intact, legs extended, arms folded across the torso, head turned slightly. And all around it, across the skull, the pelvis, the limbs, was red ochre. Not spilled, not scattered, but applied, as if in farewell, as if the body had been dressed in the earth's own color before being returned to it. At the time of its discovery, this burial represented the oldest known use of ochre in a funerary context anywhere in the world. It is still among the oldest. Dated to roughly 42,000 years ago, it is a moment from the very beginning of human symbolic behavior on the Australian continent. Ochre itself is not rare. It has been used by humans and their relatives for hundreds of thousands of years, in cave art, in body paint, in burials from Europe to Africa to the Levant. But here, in the ancient desert interior of Australia, far from any known cave system or early art site, ochre appears in one of its most intimate forms, a quiet gesture at death. It was not applied to stone, it was not smeared on walls, it was poured onto the body of a man as he lay in the silence of a lake bed that no longer held water. And that tells us something we cannot ignore. By this time, humans in this region were already expressing meaning through material. They were not just surviving. They were performing acts of memory. The ochre used in the burial did not come from the site. It had to be brought in from outside the region, likely from sources tens of kilometers away. That alone suggests planning. Someone had to collect it, carry it, grind it, and use it with a specific purpose. This was not functional pigment. It served no mechanical role in the burial. Its purpose was symbolic. That raises the oldest question archaeology can ask: why? Why did these early people take the time, energy, and ritual attention to color the dead? There are many theories, and none are definitive. Ochre may have represented blood, life force, transformation. It may have marked a person as sacred or initiated, or linked them to ancestral beings or landscapes through color symbolism. Or it may have done something we cannot yet understand, shaped by a worldview no longer accessible to us. But what matters more than the interpretation is the behavior itself. Symbolic behavior means abstraction. It means that early humans in Sahul were engaging with concepts of identity, death, and perhaps even the afterlife in ways that go beyond utility. The man buried at Mungo was not placed in the earth by accident. The grave itself was dug with care, shallow, oval, aligned with the surrounding terrain. His skeleton shows signs of age and wear, suggesting he was not young at death. His stature and build suggest he was robust, but not unusually so. There are no weapons or tools buried with him, no grave goods in the traditional sense, just ochre, which means the ochre itself was the message. It may have stood in for all other objects, a portable, powerful symbol that could communicate without form. It was the ritual. In the decades since the burial was discovered, the broader archaeological context around Lake Mungo has been extensively studied. The basin was once part of a vast interconnected lake system that flourished during the late Pleistocene, fed by glacial melt and seasonal rain. People lived here, fished here, moved through its margins as the climate shifted. By the time of this burial, the lake was in one of its intermittent dry phases. The surrounding environment was semi-arid, with patchy vegetation, dunes, and exposure to ice age winds. It was not an easy place to live, but it was home. What does it mean to bury someone in such a landscape? What does it say about community, identity, and permanence? Burial, unlike other forms of body disposal, implies place. It marks a spot. It says, here, this matters. And to mark it further with ochre says something else again. That color was used to hold memory, not just of the person, but of the moment. The death was not only endured, it was given context. And that is a leap we often overlook. It is one thing to bury a body. It is another to bury it in a way that carries meaning for others. This is not the beginning of ritual in human history, but it is one of its clearest early traces in Australia. It suggests that the people of Lake Mungo had a shared understanding of death, that they had protocols, that they were not improvising grief. The burial does not appear rushed. The ochre was not an accident. This was someone cared for, remembered, and marked. There are still many things we do not know. We do not know the man's name, his role in society, or whether the ochre signified rank, kinship, cosmology, or some other symbolic system entirely. We cannot reconstruct the spoken words of his burial, if there were any. We cannot recover the gestures, the silence, the standing circle of people who might have watched ochre fall on his face. But what we have is enough to feel that moment. Enough to recognize that this was not a one-off act of chance. It was part of something larger, a worldview in which even death had form and color. Some scholars have argued that the ochre burial at Lake Mungo fits into a larger global pattern of symbolic burials from this era, stretching from the Near East to Europe and now to Sahul. Others caution against over-connecting distant cultures. They remind us that symbolism is local, rooted in environment and language, and that what red meant in Arnhem Land may not be what it meant in the Danube Basin. And they are right. Interpretation must be cautious. But the act itself remains significant. Wherever early humans performed symbolic burials, they left behind more than bones. They left a message that humans do not simply die. We mark them. There is something quietly revolutionary about this. In a time when survival was still an hourly task, when Ice Age climates tested the limits of endurance, people were still taking time to color their dead, to place them with care, to pour meaning into an act that served no immediate purpose beyond remembrance. That choice, to turn grief into ritual, is not a given. It is a cultural decision. And it suggests that by 42,000 years ago, Aboriginal ancestors in this region were already navigating a complex emotional and spiritual landscape. The burial at Lake Mungo remains one of the most important archaeological discoveries in Australia, but its importance is not in how spectacular it looks. There are no gold masks, no towering monuments, no inscriptions, just a human, in the earth, stained red. The power lies in its quietness, its precision, its refusal to be ignored. What would it take for us to remember someone for 42,000 years? Not their name, not their biography, just the fact that they were buried with care, that others once stood above them, carrying pigment, deciding what kind of farewell to offer, that in a time before history, before writing, before states or empires, someone said, "This matters," that someone took red from the land and gave it to the dead. That act, simple, ancient, irreversible, is still speaking. And maybe the question is not what ochre meant to them. Maybe the question is what it should mean to us, not as a symbol of mystery, but as a reminder that the roots of memory go deeper than the written word, that the oldest graves do not just preserve bones, they preserve decisions, choices, acts of care that ripple forward through time, waiting to be found again. In this way, the man who lay in ochre is still among us, not as a myth, not as a metaphor, but as a fact, of ritual, of meaning, of memory given color. In the flat river plains of southeastern Australia, there are skulls that never quite made sense. They were buried but not forgotten, dug up but not explained. They were heavy, thick, flattened in strange ways, and they didn't look like what scientists expected to find when they began digging into the deep human past of this continent. They looked different, not just from modern populations but from one another. Some with pronounced brow ridges, some with artificially flattened foreheads, others with vaults so low and wide they challenged the models of human evolution taught in textbooks at the time. These remains came from sites like Cow Swamp and Kubul Creek, dated to somewhere between 14,000 and 9,000 years ago. And they asked a question still unsettled today. Who exactly were the first Australians, and how many stories were there? When the burials at Cow Swamp were first uncovered in the late 1960s and early 1970s, the excavation team was expecting to find late Holocene skeletal material, maybe a few thousand years old, more recent remains that could shed light on Aboriginal ancestry and lifeways in the late prehistoric period. But what they found instead disrupted the timeline. Radiocarbon dating placed some of the remains at more than 10,000 years old, with the earliest individuals reaching back to around 14,000 years before present. That alone made them significant. But it was the skulls themselves that forced a deeper reevaluation. The people of Cow Swamp were robust. That word gets used a lot in paleoanthropology, but here it had a specific set of traits: broad faces, thick cranial bones, receding foreheads, prominent brow ridges, and in some cases especially flattened skull vaults. These were not anomalies. They were consistent across many individuals, suggesting a pattern rather than isolated pathology. The crania seemed to echo archaic features, traits more commonly associated with earlier populations in Eurasia or even with Neanderthal-adjacent groups in fossil records. Yet these individuals were not ancient in that sense. They lived well within the time frame of modern Homo sapiens' presence in Australia. Initial interpretations lean toward evolutionary explanations. Some researchers propose that these people represented a remnant population, perhaps descended from an early wave of humans who arrived in Sahul before other groups and retained certain robust features over tens of thousands of years. Others suggested that the variation reflected a multi-wave model of migration into the continent, with different populations arriving at different times, bringing distinct morphologies and cultural practices. But soon, an alternative explanation gained traction. What if some of these unusual cranial shapes weren't entirely biological? What if they were cultural? Cranial deformation, the intentional reshaping of a baby's skull by binding or pressure, is a documented practice in many human societies. It can be used to signal status, identity, or group membership. And when forensic anthropologists began looking closer at some of the cow swamp remains, they noticed something compelling. Several skulls showed characteristics of deliberate flattening, consistent with cradle boarding or other forms of infant head shaping. The low foreheads, depressed frontal bones, and flattened occipitals weren't random. They aligned with known techniques of cultural modification. This shifted the debate. What had first been seen as possible signs of archaic ancestry now looked in part like intentional body modification, a choice, not a gene. But not all skulls in the assemblage showed these traits. Some were more graceful, more rounded, more in line with modern variation, which raised a different kind of puzzle. Why such diversity in one burial population? Why did some individuals carry the markers of a cultural cranial practice while others did not? One possibility is chronological. The cow swamp site spans a few thousand years, and it's possible that burial practices, or population traits, changed over time. Another possibility is social stratification. Perhaps only certain individuals underwent skull shaping, marking them out within the group. Or perhaps these were multiple groups, linked by shared burial space but differing in origin, belief, or practice. The bones are silent on this point. They don't record the reasons. Nearby, the site of Kubul Creek added even more variation to the picture. Dated to roughly the same period as the later cow swamp burials, the individuals at Kubul Creek showed a mix of cranial forms, some similar to cow swamp's robusticity, others more graceful. Once again, this variation was not easily explained by simple evolutionary models. And once again, the pattern pointed to a population history far more complex than a single linear ancestry. This physical diversity has implications beyond anatomy. It suggests cultural diversity, multiple ways of seeing the world, of raising children, of burying the dead. It reminds us that early Australians were not a homogeneous block, but a mosaic. Even tens of thousands of years ago, regional differences were already emerging, in tool traditions, burial customs, and perhaps in identity itself. We have to be careful not to overstate what skulls can tell us. Morphology reflects both biology and environment. A robust skull does not automatically mean a different species or even a different lineage. Nutritional stress, climate adaptation, genetic drift, and cultural behavior all play a role. But when multiple individuals from the same region show consistent traits, and those traits differ from both earlier and later populations, it signals something more than random variation. It tells us the past is not flat, it has contours. One of the most provocative questions raised by these remains is whether the ancient population of southeastern Australia was connected to different migration streams than those of the north or interior. Could there have been early coastal migrations that moved along the southern edge of the continent carrying distinct phenotypes or cultural practices? Or could isolation and environmental pressures in the Murray-Darling Basin have led to a distinct physical evolution over thousands of years? We do not have the full answer. But the burials at Cow Swamp and Kubul Creek remind us that the story of human settlement in Australia was not just about arrival. It was about divergence. Communities settled in diverse landscapes, floodplains, deserts, coastlines, forests, and adapted in place. Over time, those adaptations became culture. Culture became identity. and identity was etched not just in tools or art, but in the shape of the skull itself. Some researchers have called for caution when interpreting the robust features of these remains. There is a long and troubling history of reading too much into skull shape, of linking morphology to hierarchy, of building racial narratives from fragile evidence. That caution is important. It is entirely possible that some of the physical traits at Cow Swamp were simply normal variation within a broad and ancient population. But even within that variation, the patterns matter, because they are not static. They suggest change, and change over time suggests story. What kind of story? One where human history in Australia is not just old, but layered, where multiple waves of migration, adaptation, and innovation left overlapping traces in bone, where physical anthropology is not just a study of form, but of decision. Why choose to shape a baby's skull? Why preserve certain traits and let others drift? Why bury your dead with care, sometimes elaborately, sometimes simply, in the same stretch of ground for thousands of years? These questions do not yield to easy answers, but they push us toward a richer understanding of what human variation really means. It is not about drawing lines between people, it is about seeing the full range of what humans have been and how we became that way. So when we look at the skulls from Cow Swamp, we are not just looking at ancient faces. We are looking at a debate, still ongoing, about who we are willing to include in the human story, about whether diversity in form means difference in kind, about how cultures express their values in the body. These remains are not relics of a lost group. They are the voices of a population that shaped its world, quite literally, through the bones of its children. And that leaves us with a final thought. If the skulls don't match, maybe the model is wrong. Maybe humanity, even at the smallest scale, was always about variation. Not a single story, but many. Not one origin, but a network. A web of movement, settlement, and expression, played out in every trait, every burial, every choice to shape a head or not. The people of Cow Swamp may not have left us writing, but they left impressions. Impressions in sand, in skull, in the record of a continent that has always contained more than one version of what it means to be human. There are moments in history where the silence is louder than the evidence. The first human journey to Sahul, the prehistoric landmass that included Australia, New Guinea, and Tasmania, is one of those moments. We know it happened. We can trace the genetic and archaeological breadcrumbs. But the vehicles that carried humanity across the water, the technologies that made that first great migration possible, have left no trace, no planks, no paddles, no sails, not even a piece of rope. And yet, by at least 60,000 years ago, and possibly even earlier, people crossed hundreds of kilometers of open ocean to reach a continent where no hominin had ever walked before. So how did they do it? And why can't we find the boats? The answer, as with so much in early human history, lies in the quiet convergence of archaeology, climatology, and what is conspicuously missing from the record. The late Pleistocene world was not quite like today. Sea levels were lower, as much as 120 meters below modern shorelines. Vast stretches of the continental shelf were exposed, connecting islands into larger land masses. What we now call Indonesia was mostly part of the supercontinent Sunda. Australia, New Guinea, and parts of the surrounding region were part of Sahul, but between them lay Wallacea, a scattered chain of islands never fully joined to either continent, even at glacial maximum. That meant water crossings. Always. The shortest distance between Sunda and Sahul required a series of hops that still involved open sea gaps of at least 80 to 100 kilometers. These were not accidental crossings. They were planned. That alone reframes our view of early humans. For a long time, the standard narrative held that behavioral modernity, planning, symbolism, complex tool use, emerged only in the Upper Paleolithic, around 40,000 years ago, mostly in Europe. But the migration to Sahul predates that benchmark. And it required not only abstract thinking, but coordinated group effort, understanding of tides, weather prediction, and probably some form of navigational memory. In other words, it required boats and minds capable of building and using them. But boats, especially early ones, do not fossilize. The materials most likely used in Southeast Asia and Northern Australia, bamboo, palm fiber, light wood, are ideal for buoyancy and maneuverability. but terrible for preservation. In tropical and subtropical environments, organic materials decay rapidly. Add to that the fact that much of the ancient coastline where such vessels might have been launched is now underwater due to post-glacial sea level rise, and the archaeological void becomes understandable. We may simply be looking in the wrong place or at the wrong layer. Still, absence is not the same as ignorance. We can infer. And some researchers have done just that. The leading hypothesis is that early humans used bamboo rafts or dugout canoes, simple but effective watercraft, capable of carrying small groups and perhaps modest cargo. Bamboo, which grows abundantly across Southeast Asia, is naturally hollow and buoyant, needing little modification to float. Lash a few stalks together with plant fiber, add a pole or paddle, and you have a serviceable raft. Dugout canoes are slightly more advanced, requiring fire or stone tools to hollow out logs, but also more durable and efficient. Recent experimental archaeology has tried to replicate these journeys. Teams have constructed bamboo rafts using only stone tools and natural materials, then sailed them across the same island chains our ancestors would have faced. The results are striking. Even with limited technology, the crossings are possible. Not easy, not comfortable, but possible. And once one group succeeded, word or memory would spread. What began as an experiment becomes tradition. What was once uncertain becomes expected. Human settlement follows. So why does it matter that we can't find the original vessels? Because the silence shapes the story. When children learn about early human history, they often hear about stone tools, mammoth hunts, or fire. But they rarely hear about boats. And yet, the act of crossing to Sahul may be one of the most important technological milestones in human evolution. It marks the point where we stopped merely walking and began voyaging. It is the moment when land no longer defined the limits of our world. This maritime silence also reflects a broader bias in archaeology. For decades, the field was land-centric. Excavations happened where the ground was dry, where tools and bones were more likely to be preserved. Wet environments, coastal zones, and submerged landscapes were harder to access and often ignored. But as underwater archaeology advances, with sonar mapping, submersible drones, and sediment coring, a new picture is emerging. Ancient coastlines were not marginal, they were hubs, and somewhere along those drowned shores may lie the remains of paddles, shelters, or mooring posts that once cradled the first humans to reach Australia. There is also a philosophical question buried in the absence. What does it mean to have achieved something world-changing and left no trace? In modern times, progress is often equated with visibility. Written records, monumental architecture, medals that endure. But the first navigators of Sahul had none of these. Their legacy is written only in genes, in campsite ash, in the alignment of tool traditions that radiate from the moment they arrived. Their boats rotted. Their ropes dissolved. Their sails, if they had them, turned to wind. And yet they reached a place no one had reached before. This silence is also a kind of tribute. It speaks to the ephemeral genius of early humanity. To solve the problem of an unbroken horizon, to bet your life on it, requires imagination. It is not an accident that so many indigenous stories across Oceania honor ancestors as travelers, as canoe builders, as wayfinders. The cultural memory of sea crossings is not just myth. It is a record, preserved in story when material evidence is gone. In the end, the missing boats remind us of what we do not yet know. Not just how people got to Sahul, but how they imagined it before they ever saw it. What pushed them to leave one shore for another? Curiosity, scarcity, conflict, hope? We cannot interview the navigators. We cannot recover the vessels. But we can keep looking. And more importantly, we can stop assuming that what is missing never existed. Perhaps one day, buried beneath a submerged sandbank or sealed in a brackish peat bog, we will find a paddle, a lash of fiber, the ghost of a prow. Until then, we live with the silence. And in that silence, we hear the echo of an ancient ambition to cross the unknown and not come back. Because that is what the first Australians did. They left behind not just a continent, but a whole way of being. They looked out at the sea, and they left. And even if their boats are gone, the world they opened remains. What if everything we know is wrong, not because it was false, but because it was never found? Most of the ancient world did not disappear because someone erased it. It faded because it never fossilized. It rotted. It washed away. It never made it into stone or bone. And what didn't preserve didn't get counted. That's the uncomfortable edge of archaeology. It does not tell us what happened. It tells us what survived. And survival is not neutral. The planet is biased toward forgetting. The oldest stories, the first technologies, the earliest evidence of life on this continent, if they were carved in wood, braided from fiber, carried in baskets, or floated on bark, they're gone. If they were spoken instead of painted, if they were buried in wetlands instead of dry caves, if they were practiced inland instead of along stone-sheltered cliffs, we will never see them again. The archaeological record is not a complete narrative. It's a fluke. A narrow set of coincidences shaped by pH levels, soil chemistry, weather, erosion, animal activity, and human luck. If an entire culture once lived off seafood and discarded shells onto a beach that later flooded, we may never even find a trace. If one of the first voyages to Sahul arrived in a storm that destroyed every tool and raft they brought, no one would ever know they were there. The great illusion of deep time history is that absence equals absence. But absence in science is not the same as proof. Absence could just mean that we haven't looked in the right place, or that we did, but erosion got there first. Radiocarbon dating has helped anchor a great deal of our current knowledge, but even that has limits. Dating depends on organic remains, and organic remains depend on preservation. The deeper we go into time, the less material survives. A shell midden in a dry cave might survive 50,000 years. A wooden canoe in a swamp might survive 500. But both are equally ancient in origin. One just got lucky. Even more invisibly, the way we study the past is shaped by what we expect to find. That's another bias. The questions we ask, and even the places we choose to excavate, are shaped by present-day narratives. If early archaeologists expected advanced cultures to live in stone houses and use polished tools, they may have completely overlooked the equally advanced lifeways of nomadic people using ephemeral technology. If a site is interpreted through a European lens of progress, cities, agriculture, metallurgy, then a culture that deliberately avoided those pathways for ecological or spiritual reasons might be misread as primitive. That's not just wrong, it's unfair. Even modern mapping methods have their flaws. Ground-penetrating radar, LiDAR, and satellite imaging can reveal structures buried under soil and forest. But they can't reconstruct vanished shorelines, they can't model myths, and they can't tell you what's not there. No scan will show you the ghost of a ceremony held on sand that's now sea. No algorithm can fill in the memory of a painted bark shield that crumbled 2,000 years ago in a floodplain. There are ghosts in the Midden, traces of lives we will never recover. What if everything we know is wrong? Not because it was false, but because it was never found. Most of the ancient world did not disappear because someone erased it. It faded because it never fossilized. It rotted. It washed away. It never made it into stone or bone. And what didn't preserve didn't get counted. That's the uncomfortable edge of archaeology. It does not tell us what happened. It tells us what survived. And survival is not neutral. The planet is biased toward forgetting. The oldest stories, the first technologies, the earliest evidence of life on this continent, if they were carved in wood, braided from fiber, carried in baskets, or floated on bark, they're gone. If they were spoken instead of painted, if they were buried in wetlands instead of dry caves, if they were practiced inland instead of along stone-sheltered cliffs, we will never see them again. The archaeological record is not a complete narrative. It's a fluke. A narrow set of coincidences shaped by pH levels, soil chemistry, weather, erosion, animal activity, and human luck. If an entire culture once lived off seafood and discarded shells onto a beach that later flooded, we may never even find a trace. If one of the first voyages to Sahul arrived in a storm that destroyed every tool and raft they brought, no one would ever know they were there. The great illusion of deep time history is that absence equals absence. But absence in science is not the same as proof. Absence could just mean that we haven't looked in the right place, or that we did, but erosion got there first. Radiocarbon dating has helped anchor a great deal of our current knowledge, but even that has limits. Dating depends on organic remains, and organic remains depend on preservation. The deeper we go into time, the less material survives. A shell midden in a dry cave might survive 50,000 years. A wooden canoe in a swamp might survive 500. But both are equally ancient in origin. One just got lucky. Even more invisibly, The way we study the past is shaped by what we expect to find. That's another bias. The questions we ask, and even the places we choose to excavate, are shaped by present-day narratives. If early archaeologists expected advanced cultures to live in stone houses and use polished tools, they may have completely overlooked the equally advanced lifeways of nomadic people using ephemeral technology. If a site is interpreted through a European lens of progress, cities, agriculture, metallurgy, then a culture that deliberately avoided those pathways for ecological or spiritual reasons might be misread as primitive. That's not just wrong, it's unfair. Even modern mapping methods have their flaws. Ground-penetrating radar, LiDAR, and satellite imaging can reveal structures buried under soil and forest. But they can't reconstruct vanished shorelines, they can't model myths, and they can't tell you what's not there. No scan will show you the ghost of a ceremony held on sand that's now sea. No algorithm can fill in the memory of a painted bark shield that crumbled 2,000 years ago in a floodplain. There are ghosts in the Midden, traces of lives we will never recover. What does it mean to be first, in a place where time has no edge? The idea of being first sounds simple, but in a continent measured in ice ages, stories, and songs older than civilization itself, it becomes slippery. First to do what? To arrive? To belong? To remember? When your ancestors have been in a place for tens of thousands of years, the word first doesn't feel like a milestone. It feels like the wrong question. In Australia, the scale of human continuity challenges the way most cultures even imagine time. This is not a history of conquest, empire, or collapse. It's not measured in dynasties or inventions or wars. It's measured in the shape of the land, in the rhythm of seasons, the breath of rivers, the silence of deserts that remember. While much of the world learned to measure history by change, here it was also measured by staying. Staying with country, with language, with obligation, with story. That kind of continuity is rare, not because humans can't do it, but because most were interrupted by ice, by flood, by colonization, by the loss of land. The Australian continent holds one of the longest unbroken relationships between people and place anywhere on Earth. And that doesn't just say something about the past. It says something about time itself. Time here is not always a straight line. It spirals, it returns, it loops through ceremony and landform. The ancestors are not behind you, they are here. This matters, not just for archaeology or genetics or maps. It matters for identity, for what it means to be from somewhere, truly from it. In most societies, the story of origins begins with a rupture. We came from elsewhere. We arrived. We began. But what if your story doesn't begin with arrival? What if it begins with presence, and that presence never left? In that case, belonging isn't a claim. It's a responsibility. It's not about owning the land. It's about being part of its ongoing expression. You're not the author of the story. You're one of its verses. This is what deep time teaches us if we're paying attention. That survival is not just about adaptation to climate or terrain. It's also about continuity of meaning. Tools change. Habits shift. But meaning, the kind that binds people to land, can hold steady across thousands of generations. And when that continuity is maintained not by writing or archive, but by song and ritual, then every person born into that system becomes part of the transmission. You carry the future by carrying the past. For most of human history, we didn't need history books. We had memory, we had place, we had repetition and rhythm and community. And in Australia, that way of knowing has lasted longer than almost anywhere else. It reminds us that history does not need to be fast to be profound, that progress is not the same as motion, and that you don't need to build monuments to leave a mark. Sometimes the land itself remembers for you. So what does it mean to be first? Maybe that word isn't useful anymore. Maybe what matters is not being first, but being in relation, to land, to people, to time. Maybe what matters is not the beginning, but the continuity, the fact that it didn't stop, that through all the fires and floods and silences, someone still sang. Someone still remembered where to go when the stars were in a certain position. Someone still knew the name of a place that hasn't been dry in 10,000 years. In that sense, the people of this continent aren't just part of history, they're part of its memory system. And when we treat that memory as valid, as data, as record, as truth, we don't just learn more about the past. We learn how to belong to the future, because the future needs memory too, especially now, especially in an age of erasure, speed, and forgetting. The lessons of deep time aren't just archaeological, they're ethical. They ask us how long we're willing to listen, how much patience we have for a story that unfolds in generations instead of news cycles. They ask whether we still know how to learn from people who did not write books but remembered everything that mattered. They ask whether survival without destruction is possible, whether identity can be shared across millennia, whether a place can carry its people, not just for a season, but for an epoch. In the end, the story of this continent is not about being first, it's about being home, and staying, and remembering, and singing the land back to life every day as if it never left. Because for those who belong to country, truly belong, it never did. We may never know the names, we may never see the tools, but if we remember that the record is incomplete, that it always will be, then maybe we become better listeners, not just to the layers we excavate, but to the absences themselves. Because sometimes, the most powerful ghost isn't a thing we find, it's the one we can't. Thank you, fellow sapiens, for wandering this ancient coastline with me, for stepping into deep time, for remembering that history doesn't always leave behind monuments. Sometimes it whispers through ochre, or travels by canoe, or hides in the layers of a shell midden. If this helped you rest, helped you think, or simply helped you slow down, I'm grateful you were here. If you believe more people should know this story of land, of memory, of the first humans to map a continent with their feet, you know what to do. Like, subscribe, share it with the sapiens in your life, and tell me, are you listening in bed, while working, or somewhere across the vast map of this planet I'll never fully see? And as always, stay curious, stay calm, and I'll see you in the next story.